Yeah, my name is Raghavan Srinivas, but I go by Rags. I'm work as developer advocate at DataStax. I've been doing NoSQL for a long time. Obviously, done relational databases as well for a long time. Basically, I've worked as a developer advocate, doing Java, kind of more of the application development, the inner loop, and so on. I love this group because our main mission is to level up your skill, no matter where you are. Whether you are a really a beginner or a experienced person, and hopefully we can talk to you about K8ssandra and share the passion that we have, because like I said before, I think it's a great match for NoSQL and Kubernetes to come together, and you will see that in action today by trying it out yourself. So that was a brief introduction for myself.
Right, and I want to keep my introduction even shorter. I'm developer advocate lead at DataStax. We do a lot for Cassandra, K8ssandra, Stargate, and many other technologies we work with, but most of all for developers who are interested in these technologies. Now let's move on. That's not only two of us behind this workshop, but there is plenty of people who invested themselves a lot into that and put many effort into develop the software and develop the workshop and develop everything what we are using for that workshop and many others. And on our stream, on our YouTube channel, we have at least 2 workshops per week. So we will be happy to see you joining DataStax developers on YouTube. Now, a little bit of housekeeping and setup. So we have a pretty huge program today, and we will see what's going on to happen a lot. First of all, for this workshop, we provide a special certificate of completion, or we call it Achievement Unlocked Badge. If you follow this workshop with us, you have to watch the video live or record it, ask your questions, do the practical steps, make the screenshots of those steps, and submit them at github.com K8ssandra workshop. In the wiki, you will have a link on how do you submit that, okay? Now, things you need to know. First, most important link for us today is github.com K8ssandra workshop. And you have a K8ssandra community Discord link. And we suggest you to join community at k8ssandra.io and of course, Twitter, K8ssandra. K8ssandra is a big thing, and I hope in the end you will like it as much as we do. For today, we have multiple installation options, so you can prefer the one you like the most, local, cloud, and installation. First of all, local installation is for any kind of a development purposes. Are you using Kubernetes and Docker? Good. Are you using Minikube? Also good. Whatever you like, that's great. Then for today, we also use.
So just a little bit to add, Alex. There,
yes, please.
There are quite a few options here, and pretty much we have tested the instructions for most of it. Siva kind of straddles the two. So even though it's on the cloud, we have made it more of a local install because the idea is that you can effectively use it as like a local cluster. But there are some options where you can connect, and you will see that today in action, where you can deploy an application and essentially access it like it was in the cloud or something. So Siva kind of straddles that. There are some issues with traffic right now, and that's why it's not going to work in a cloud mode. But traffic is being worked on, and then you can kind of use it like a GKE or a EKS or AKS. But for now, these instructions are going to work on pretty much kind, Minikube, or whatever you choose.
Yep. Okay. Good then. maybe you will proceed from this point if you're ready. Rex?
All right. So let's go to the next slide.
Okay. You just can start. Okay, I can do it. Yeah, sure.
Yeah. Would you like to share my screen, Alex? Is that the easiest?
If you wish, yeah, we are in Zoom, so you can just start sharing.
Let me do that. That might be the easiest, right?
And meanwhile, there is a question in chat, a good question I want to mention. Is this workshop suitable for beginners? And my answer is it very depends on your definition of a beginner. We do recommend it to people with at least some Kubernetes knowledge, I would say.
Yeah, we have kind of prepared the workshop in a way that you could get started. Most of you will probably be familiar with kubectl, using the kubectl command. So if you know that, then you're probably good. And by the way, can you see my screen, Alex?
I can see you, but I cannot see your screen so far.
Let me see if I can. All right.
Oh, yeah, that looks better.
All right. So so the first thing you would probably do is kind of figure out where you're going to install K8ssandra. Whether you want to do it. And thanks to Civo, we have a link where you can get a Kubernetes cluster pretty much in a couple of minutes. I've already created one, and you can use that. This is available only till a couple of days, or maybe it'll go away in a couple of days. So just keep that in the back of your mind if you want to use this infrastructure.
Yes.
Okay. I think this pretty much talked about what we said before, which is basically you can use the local install or the Civo instance, or you can use a cloud instance if you have a way to stand this up either in GKE or EKS or AKS. And really all that you're going to do is, you'll see, we'll just follow the steps outlined in the workshop. There is one step that, we need to, remind you a couple of times. It's called out in the workshop pretty explicitly, but just want to make you aware that you may want to replace this UR address, especially if you're using a DataStax provided VM. But if you're using Civo, you don't really need to do that. But once again, traffic is working. Traffic is kind of the ingress. So we're going to ignore the ingress part today for Civo. But if you want to set that up later, you can do that. And you're going to pretty much follow the same steps as you were going to set up, if you're going to do the DataStax VM. So maybe it's left as an exercise to the reader, so you can try this out later. But for Civo, you don't need to replace this UR address. There are different YAML files, and as you walk through the workshop, we can take a look at that. Are we ready to jump into Menti, which is really our cool part, right?
Yeah. Good. So we are ready to jump to Menti.
Yeah, and you may want to share your screen, Alex, right?
Yeah, sure, I know.
Yeah.
I just want to check what you are ready to switch to Menti. So what is a Menti and what's going on? Take a look. We use Menti for two purposes. First one, you know what? You can ask us questions, that is fair. But without Menti, we cannot ask you questions, that's not fair. So first we use Menti to ask you the questions and understand what's going on, like what are your primary topics, what should we focus on, and so on. You will see in a moment. But second, and the most interesting, is we use Menti to play a game at the end of this workshop. And in the end of this workshop, you can play a game with us, answer questions. If you do it fast enough and if you give the right answers, you will get prizes from DataStax. So First, for now, it's not the quiz, it's not the competition, but just the setup part so you can start using Menti, make yourself familiar with it, and you will know how it works. It's very easy. You just go to menti.com and enter the code 42541711, or just scan the QR code on the shared screen. And then you will be in. One more time, please go to menti.com 42541711. You don't have to do it, but if you don't do it, you cannot participate in the game in the end of this workshop. So I do ask you to join. If there are not too many people join the Menti, there will be no real competition, and we love real competition on our games. So we want to be there. A lot of people, with everyone having a chance to win the prizes. And we go with the first questions. That's not yet, do not rush. That's not yet the quiz. How much experience do you have with Kubernetes? Okay. So I see there is someone who never have heard about that. Welcome to KubeCon. That's a conference dedicated to Kubernetes. You are going to have a lot of things to learn here. And I see most of the people known but never use it once or two, or even some people use regularly. And hey, we have some Kubernetes experts. That is great. Good. So, okay, that makes us understand, like, what about you? And well, if you never have heard about that, that's going to be a rough ride for you. By the way, if you are interested in Docker and Kubernetes, we have a special workshop series on Docker and Kubernetes you may find on our YouTube channel, DataStax Developers. How many KubeCons you have attended before? Have you attended many? First one, that makes sense, and welcome. 1 or 2, 3 to 5. Hey, we have some people with a real experience here, but for most of you, that's the first one. Our congratulations. We love this workshop, and we are happy to see you here. And
did we ask a question of whether you're attending KubeCon in person? We probably didn't, right? No.
Not for the last couple of years at least, and we have only 4
what I meant
persons
is we
who
didn't ask a
attended 3
Menti
to
question,
5.
right?
No, we don't have Menti question. Have you attended live or virtual?
Sure.
So you can ask in chat, but not on Menti. Good. Now, very curious, where are you? This time it's North America KubeCon, but because of this ability to attend virtually, you can be from basically every part of the world. And looks like we have people from nearly everywhere. Anyone from Australia, or Australia is sleeping already?
Very cool to see dots all around the world, right? It's so cool.
Yes, that's amazing.
Yes.
And we have people from all around the world. Yeah. Hey, Cairo here. I see Brazil. I see some part of southern South America, but I'm not sure if it's Chile.
What's that island? Is that Indonesia on top of Australia?
That must be. I'm not sure. What is it exactly?
Yeah, I'm curious.
Yeah, that is interesting. Writing in the chat, it's Indonesia, mostly probably. I think so.
Maybe.
Philippines.
Yes, it is
Indonesia and Philippines.
Okay.
Right. That very much makes the sense. Like, that's quite a global audience. Very well. You know what? Don't worry about the prizes. We ship worldwide. We may expect some delays with delivery, but in the end, you will get your prize if you finish in the top 3. Now we are going to harder points. How much experience you have with Apache Cassandra?
Too difficult to click
heard, but never use it. Practical experience. Hey, is it a database at all? Basic understanding and or experience. Cassandra expert. Hey, is it Cedric in the chat? Good. So Cassandra is one of the best and most powerful technologies in the NoSQL world. So Today, we will make you familiar with that. Then Prometheus, does it sound anyhow to you? Have you heard anything about the Prometheus in the context of KubeCon? Okay. We have people who has a real experience with Prometheus or daily usage. Some people with some experience. Something about monitoring, never use it. God of Fire? Well, yes, but no, not today. Today for you, Prometheus is not a God of Fire, but the monitoring, well, not only monitoring, but the tool we will use to understand and keep under control our databases on Kubernetes. Grafana, does it sound to you anyhow? Have you heard about that? I know how it works. I know it, but I never used it, never heard of it. That is good as well. So it looks like for some people, we have a lot of things, of new things to cover today. Good.
We have a few Grafana experts, which is nice.
Yeah, well, Grafana is a kind of industry standard.
Yes.
So that's not a big surprise. And many people say Grafana is a monitoring tool. That is wrong. Grafana is data visualization tool. So you can use it for monitoring, but it can offer you so much more. I like Grafana. So operations or development? Are you more into the operations administration, or are you more into the development, or you stay on the both sides, which is also very a lot. So no surprises, DevOps or operations mostly. KubeCon was mostly for those sides. So this distribution makes really a lot of sense. And as most of you have voted already, and we have to move on, are you going to use that deployment on your own local laptop, or are you going to use cloud training instance? Okay, like almost to 50-50. That is interesting.
That's what we're thinking, right? So
yeah. You know what? On previous KubeCons, it was different. Now more and more people tend to use their laptops, and like a couple of workshops ago, it was not close to 50-50. It was very much for cloud training instance. Interesting. Okay, but we support whatever you decide. We support you in any of your choices.
Yeah.
And finally, are you certified Cassandra developer or administrator? I know that most of the answer will be for nope, but if there are any, I would like to know about that as well. So looks like most of you are not certified for that. And that means what? For currently 68 people have answered and still counting. Oh yeah, we have one certified. Congrats, well done. So we have a great news for everyone who is not certified for Apache Cassandra as a developer or administrator. DataStax sponsors your education and certification for Apache Cassandra to become a certified Cassandra developer or administrator. That means what you can pass our courses online for free, and they take an exam online for free and become a certified Cassandra developer or administrator completely free of charge. Thanks, DataStax. I love my job, actually. So if you want to be better in the powerful NoSQL world, they have a very good news to you. So we will explain it a bit later in the last part of the workshop. Now let's proceed. So thank you.
So Alex, do you want to remind the attendees that this was just a practice, because later we will come up with the real questions, right? The technical questions, right?
Right.
So now that
my next phrase.
You've kind of got your muscle memory ready. You will have fun later as well, because there are a couple more opportunities to kind of participate in this. The thing is, not only do you need to get it right, but you also need to be fast, right? And that is kind of hard, especially for me. I know I have trouble being fast, but just keep this in mind now that you're used to it. We will have one more later in the workshop.
Right. So yes, but that was my very next phrase. Keep this window open. We have a quiz in the end of the workshop. So when that will be a real competition with real prizes.
Perfect.
But that's enough for now. And we can proceed. And we go with basically a story of the databases on Kubernetes. Not story like history, but a story like something what's going on and what you need to know to understand what are we focusing today at this workshop. So cloud application architecture from the very, very, very high level, we basically can split into 3 simple parts: applications, data, and infrastructure. So application is not necessarily microservices. It still can be a monolith, and it may be good what it's monolith. Not everything should be reworked into microservices. But anyway, whatever they are using, they are going to work with the data. We're going to persist this data on disk, so it's not lost. We are going to stream some data in case we need event streaming. And we are going to analyze some data pretty much often. And finally, it's all going to be running on some infrastructure, consuming compute, networks, and the storage. Very 3 layers. It started then with monolithic applications using databases. Then it wasn't legacy databases for sure, running usually on your own on-premises data centers. You all know that was a traditional approach, very familiar to many of you. Now, then people realize it, what modern world, first of all, clouds with all of their powers and microservices may be much better fit for the many, many, many cases. But you know what? You cannot just say a magical word and transfer your monolith into multiple microservices to modern purpose-built databases to the cloud, using databases as a service, using cloud infrastructure as a service. Usually it doesn't happen like that. So migration started and many companies using hybrid cloud already. It means what they still have their own on-premises data centers. They still use those databases. They use it to use for dozens of years, and still you have these monoliths, but new services are being developed usually as microservices often and running on the cloud already, having this hybrid cloud, not because it's a perfect solution for them, but just because you cannot migrate a huge major application within single clicks. It's not so easy. And of course, here we started to speak for the modern parts already for purpose-built databases. About databases as a service, those are getting more and more common and well-known nowadays. And of course, it was actively using benefits of cloud infrastructure as a service. And then finally, Docker, Kubernetes, and containers have come. Actually, containers were with us for a long, long time, but before Docker times, there were no simple and convenient way to use them. And Docker became like the #1 thing what provided a convenient way to use originally LXC Linux containers, and then they changed it low-level engine to support some more things. And here came the Kubernetes. Kubernetes was originally developed by Google to solve Google-level problems. But when many companies realized what they cannot now live without containers, and if you want to manage containers on the real scale on production, you have to go with Kubernetes. There were a Docker swarm those times, but actually it was too late. Docker swarm at that moment was not delivering any. It wasn't just ready, let me say so. I was exactly doing research for my company if we should go with Docker Swarm or Kubernetes some years ago, and Kubernetes was the obvious choice. And then many companies decided, let's run it all ourselves in Kubernetes. And many companies, many projects, many people went for it and found out what actually it gives a lot of benefits, but also there are some downsides they have to consider. And still using cloud or self-managed infrastructure as a service, doesn't matter if it's an OpenStack or I don't know, Amazon Web Services, for example, but still having Kubernetes engine above, having databases already above that or outside of Kubernetes, but still close to it, and microservices running on top of it, but never using databases as a service, and focus it to keep full control over the databases. And the point is, a database layer is not easy, and there is a lot of operations and a lot of things to do. And in the last years, more and more companies start to think of using database as a services, basically using the same approach in running their applications, running their microservices as Kubernetes pods, but also using already more software as a service, database as a service, simplifying their work because it gave them more time to take care of what they want to focus on instead of just running operations. If you have experience on running operations on for any kind of a distributed database on your own, you know exactly what I mean. There is really a lot of things to do. What's the current state of these path to the clouds, path to the microservices and Kubernetes hosted applications? Usually, depending on your own definitions of success, first of all, because there is no one size fits all, we still speak of cloud managed or self-managed infrastructure as a service with Kubernetes engine. Now, here can be a trick. It can be your own Kubernetes or something like, for example, Kubernetes service from Amazon Web Services or Azure or Google Cloud. Working with data tier on the purpose-built databases and microservices running on top of them, or not better to say on top, but alongside with them, with proper observability stacks for your applications and for your data. And that's a very important point, because if you don't have proper observability, you cannot manage what you can't measure. And observability stack became very, very, very important. And then finally, getting closer to what we have now, we speak about the single observability stack, what helps us to keep control on everything and literally each and every aspect of the data and application we are running together. And there were a lot of skepticism about running your data on the Kubernetes. That is, well, I was in this crowd, that's for sure. You can be absolutely sure I was very against databases as services, and especially running databases on Kubernetes, because, you know, first of all, containers were born to be stateless, and containers works great as long as they are stateless. But then you run into something you want to be stateful, especially for databases. Kubernetes those times wasn't perfect for it. That what raised it. Actually, this skepticism. Many people thought what you cannot run your databases on Kubernetes. For this point, by the way, I do cancel. If you ask what I was as skeptic as I do, as I did, then I do recommend you to read this article from Christopher Bradford, our colleague and project manager for K8ssandra, who was also a skeptic, like many of us. And finally, you know what? As he was skeptic for data on Kubernetes, now he develops and runs the development of K8ssandra, which is basically data on Kubernetes. So it's quite an interesting transformation, and I do suggest you to take a look at it. That was.
Yeah, and I myself, I come from the Cloud Foundry side of the world, and you know, the concept of the 12-factor app, right? You know, which is really stateless apps was very popular. And stateless apps are great, but you really need, you know, data to be persistent. You know, you think of any application, admittedly, it was not easy initially, but you know, we are well beyond that. And you will see today how you can install K8ssandra yourself and kind of play around with it and do the routine tasks that everybody does. You know, and that's really what's exciting because you can, it's really democratized the operations of databases on Kubernetes.
Right. Okay. So this talk or this workshop is a part of a Data on Kubernetes community. There is a huge community, DOK, Data on Kubernetes, which basically focused to make these, take care of the reasons what brought this skepticism to happen, because it was reasonable for quite a long time. Okay, and they are going to speak about what is K8ssandra and why do we speak about that today. So K8ssandra is a great tool. It's an open source project. It's mainly developed by DataStax, but it's an open source and you always can join the development. You can use this project for free on EKS or whatever cloud provider for Kubernetes on your own self-hosted Kubernetes. Before, I used it to call K8ssandra cloud-native scalable Cassandra with administration tools and easy data access. Apache Cassandra is a database, NoSQL database. We will mean a lot, but now I say it's a cloud-native scalable data tier with administration tools and easy data access. Why and what changed? You will see soon, but that's a very important point. Originally, idea was to help Cassandra running on Kubernetes with ease, because there is quite a lot of configurations, knobs, buttons, levers you have to push, and with a proper help, it may be much easier, especially when we speak about multi-regions, multi-data center deployments. That's going to be a very long story. But later, over this project, there were many secret, of course, not for real secret, but many more interesting ingredients added. So now K8ssandra is not just Cassandra on Kubernetes. It is way much more. We will show you today. First idea was to develop a Cass operator. If you don't know what is a Kubernetes operator, don't worry. We will explain it today. But the idea to use this Cass operator didn't really fit. Now we built a Kubernetes operator for K8ssandra to take care of the many tools. You will see soon, but in general, that must be clear. What it's not enough to just run a database. Do you need to understand what's going on in this database? Yes. Do you need to have a proper monitoring? Yes. Do you need to have proper tools to run backup operations? Yes. And there are some more you need to know. So that was also very interesting reading on the newsstack.io, how we push it Helm to the limit and then build a Kubernetes operator. And I do recommend you to read it. That's a pretty interesting story by our very own Jeff Carpenter and John Sanda. By the way, Jeff Carpenter is an co-author of Cassandra, the Definitive Guidebook. And John Sanda is one of the best software engineers I've ever seen. So those two make a perfect team to write something what may take your attention.
Yeah, and one of the things, Alex, if I may add here, is that we're
Sure.
going to show a multi-region Cassandra in operation. So essentially, it's going to be two clusters, and we're going to network them together, and you'll see that in action later. And the idea behind that is that again, you can take Helm only to a certain degree. After that, you have to have other components that can help you, and that's where the operator kind of comes in, because what it's doing is it's constantly monitoring the state and kind of keeping track of how many instances are there, what is the desired, what is the current, and kind of matches them and does the routine operations for you that otherwise you would have to worry about it yourself, right? So this block kind of walks through how you can do this multi-region Cassandra and a bunch of other things that are enabled by this new, what we call as the K8ssandra operator.
Right. Okay. So One of the problems of traditional databases, they go for vertical scalability. And that means what instead of using more machines and spreading over multiple servers and data centers like you could do with your applications, you go and scale your traditional, usually relational databases with vertical scalability, replacing the older one with one bigger, new, more expensive. It was an old approach. It's easier to get, and it is has some downsides. First of all, it's getting very expensive very soon, and that still provides single point of failure. So if you know a company running application on Kubernetes, but running a database outside of a Kubernetes, mostly probably they go for vertical scalability. Now, applications on Kubernetes, and not only, go much more often for horizontal scalability. That means what when you need a more powerful computational cluster, you just add more servers, and your Kubernetes takes care of that and automatically can reschedule your pods over those new servers. And that's exactly matches the Cassandra scalability strategy you will see in a moment. So now we go to my favorite topic, Apache Cassandra, and why it was chosen to be the foundation of this data layer on Kubernetes. Why K8ssandra is K8ssandra, why K8ssandra is based on Cassandra, not on Mongo, for example. There are multiple reasons, but let's first of all, let's discuss the main features of Apache Cassandra, what people and why many companies using that. So first, Apache Cassandra was originally developed at Facebook, and later it was donated to Apache Software Foundation, non-commercial, non-profit, open source foundation, to become a top level of it very soon in 2010. Current latest stable version is 4. It's distributed and decentralized database. And you know what? Those two words take only one single line. Okay, distributed, decentralized database. Okay, so what? How many master nodes does Cassandra need? Cassandra is decentralized. It has no master nodes. And it's distributed, so it can handle any amounts of your data, just add more servers. Cassandra is a perfect fit. There are just no better fits to a Kubernetes ideology. And we fit elastic linear scalability if you need more capacity, if you need more velocity, if you need to handle a higher amount of questions, you just add more servers to a cluster, no vertical scaling, but horizontal scaling, and you are good to go. It has a globally available way to work. So if you need to have multiple regions, multiple data centers, it's a perfect fit and you can go with it, and it works seamlessly. It's obviously highly performant. Cassandra is used by the titans like Apple, like Netflix are one of the biggest Cassandra users, not only users, but also developers. Now, it's very well known for highest possible availability and fault tolerance, or some people prefer to say disaster tolerance, because that's obviously a very important way for any modern application to be fault tolerant or preferably disaster tolerant. Now, with the tunable consistency, we will say a bit more about that in the end, but very often people say what Cassandra is eventually consistent. If someone tells you what Cassandra is eventually consistent, you better say Cassandra is configurably consistent or tunably consistent. That will be better way to phrase the words. And in general, that's a partitioned row store. So there are no joins. It's not a relational database. You cannot make a query run over multiple tables because you know what? At the big scale, really, those joins don't really work if you need your queries to be fast. So when you have thousands of servers for your data, that won't work. how do you work better with Cassandra? We have a dedicated workshop about that, so we won't stay for too long on Apache Cassandra, okay? We have more things to cover on today regarding the K8ssandra. But there are two main concepts you need to understand. Data is distributed and data is replicated. What does that mean? First of all, data is distributed. Take a look. On the right side of my screen, you have the simple table, population per city, per country. And that basically means what in the, like just a simple table, 3 rows, country, city, population. How many people live in the city? I guess numbers are a little bit outdated right now. You may need to refresh them later, but that's not really matter. It's just a demo. So how this normally would work with traditional relational databases. Even if you already have some cluster, let's say, the full copy of the table will be stored on each and every server, right? And then there is a second problem. This data works well and your server relational databases work well as long as all your data fits to a single machine, like master, slave, slave, or primary, secondary servers, or whatever you call them. Idea is the same. At some point, as your data grows, you can't store it all on a single server, and then you have to go for something very bad. It should be considered a crime. It's called sharding. Sharding is a very, very dangerous thing. Sharding is a very much of pain and manual thing when you understand what your data in your relational database doesn't fit into a single machine, and you have to split it to parts. It's a manual project. It's a manual process. It's basically makes it very hard to use any kind of relational database features like joins and things. And it's quite painful. Every time you need to add a node, or if you have to remove a node, you have to do a lot of manual work. So in short, friends don't let friends use sharding. If your database is grown enough to think about sharding, you better think on the migration on Cassandra. It will be in the end much easier because Cassandra was created to handle the problems of such a scale. Okay, but how does Cassandra solve this problem? With partitioning, which has the same idea like sharding. You split your table over multiple parts on the database, but it is automated completely and you don't have to take care of it manually. You just have your table split into parts, distributed over multiple servers. If you add more servers, like you expect, you are Netflix or Netflix employee, let's say, and you expect the release of last episode of Games of Thrones. You know what, everyone in the world will go and watch it, and you have to make your database ready. Then what do? You just bring more servers to the cluster. Cluster sees, okay, I had like, let's say 1,000 servers. Now I have 2,000 servers. It means I have to move the partitions. Partitions being automatically spread over those servers. So now each server takes care of a lesser amount of partitions. And in the end, every server is able, so cluster overall is ready to handle much higher workload, much higher amount of requests. And then if you are done and no one is going to, so the demand on your service is decreased and you don't want to pay prices for more of a cloud infrastructure, you know what, it will be no big pressure because everyone is sleeping, eating, discussing on Reddit former series. You can then take down some of those servers. And Cassandra cluster will really understand the situation. Okay, you are decommissioning the servers. We expect not too many load. Let's get those partitions back to the servers what they remain. And therefore, you will pay less for the infrastructure. If you have any experience with sharding, you just understand how much it matters, what it's all fully automated. You put more servers, you remove servers, and cluster does all the work for you. It is amazing. I absolutely love partitioning. But partitioning is not enough. Because you know what, with data spread over multiple servers, what will happen with French data for Paris and Toulouse if this server is down? If this server is down, when we cannot access data of France, and that would be quite sad because you know we have a lot of great people in France. So let's take care of them. Okay, let's protect them for this issue. It's called replication. And Cassandra uses replication all the time. That's how it guarantees highest possible availability at the market of the database management services. Replication factor is something what defines how many rows, how many times a row, or better to say partition, will be stored on different nodes. That means what your data is stored, every row, every partition you have stored not on the single server, but it's stored on, usually we recommend replication factor 3, so it's stored on 3 different servers. That means what your data then being dispatched to multiple servers, and that's brings us to a situation on how do we properly distribute this data over multiple servers. Idea is, first of all, we may have multiple data centers, and that matters a lot. Keep your data close to your clients, and we keep things disaster tolerant. But meanwhile, within a single data center, you are going to have multiple server racks. Or if you are using managed cloud solution, then if you will go for a cloud, we will speak not about data centers and racks, but we will speak about regions and availability zones. Mostly probably you know what I mean if you use cloud already. So what does that mean? We have, what's the purpose of the availability zones? To raise fault tolerance, to raise disaster tolerance. Then your availability zones are basically, technically, for example, for AWS, those are different data centers with independent power sources and independent network connections and so on. There is a probability for what one availability zone will fail together because of a power outage and so on, but the other availability zones will work successfully because they have independent power supply, for example. And same goes for the data center. Servers within the same racks have higher chance to fail together because server rack may have, for example, the same power supply, and the power outage may take the whole rack down. Now, how exactly Cassandra puts your data, puts those replicas because of replication factor 3. Normally we have 3 replicas. It will intentionally put it into the different racks or into different availability zones, so you can make it, and that is again automated. So especially with K8ssandra, for Cassandra running on your own, you have to think more about that. But the general idea is Cassandra manages replicas, trying to keep your data as far away from each other as it's possible within a single region or within a single data center to reach the maximum level of the high availability or highest availability. And last point for me, Cassandra scales horizontally. That means what if your data model done right, and again, guess what? We have a dedicated Cassandra data modeling workshop on our channel, which really deserves your time. But if your data model done right, then Cassandra scales horizontally. And if tomorrow you have to handle the doubled workload, you can just double amount of your servers, and it will be perfectly fine. Finally, Cassandra was born to run on multiple data centers and completely platform agnostic on hybrid cloud and multi-cloud. that makes it very capable, and that makes it a perfect fit, as I said, for Kubernetes, with ability to run over multiple data centers, still combining at the single cluster over multiple data centers, and ability to run simultaneously on AWS, Google Cloud, Microsoft Azure, and of course, your own on-premises data center. And hey, Rex.
Yes.
So, you know what? I was talking for a long time. Now it's your turn.
Absolutely. Okay. So let me go into a little bit fast forward here, right? And
right.
So the installation is pretty straightforward. The first thing you need to do is, as we call it, pick up the red pill or the blue pill, right? The blue pill is something you're going to install on the cloud. So if you have a cloud instance already running, then you're fine. You're going to use that, right? But if you don't have a cloud instance, you don't have something installed locally, you're going to pick the blue pill. The red pill, right? Which basically is, I may have it the other way around, but you get the idea. You're going to install it locally. I know in the chat, people are already starting to install it on Minikube, and some people have tried the DataStax provided VMs. And essentially, you have two paths. One is the DataStax provided VM, right? And the other is the local or the CIVO. So you can get an instance in CIVO running up and running in a matter of a couple of minutes. Okay. So the first thing
it was really quick, I have to say.
Go through the local setup, and I will walk through that. I'm not going to go through the whole thing, but essentially the idea behind, can everybody see this? Do you want me to?
I think so. Or? Yeah, that looks good to me. Yeah. At least on my side, it looks good.
Okay, fantastic. So obviously, most people have Docker, but we put it there anyway, right? And then you have to have a Kubernetes cluster. And this is where, the resource requirements for local clusters are given here. Typically, you need like about 8 GB of space or something like that. If you don't have it, then, I think the recommendation would be to install CIVO, okay? But if you have the resources, there are a couple of options you can go. One is Kind, the other is Minikube. So you can go either of those, right? It's always going to be, like either a local cluster, local install, or a cloud install. But within a local install, it may be a little bit different for CIVO, a little bit different from Kind, a little bit different from Minikube, but we will call it out, wherever it's relevant. The first thing you're going to do is, I'm sure most of you already have this. You have the kubectl, which is a command line tool. Obviously, there are other options that you can use. Many of us use Lens, which basically comes with kubectl. And nowadays, most of the IDEs also come with kubectl command. But as long as you have access to kubectl somehow, I think you're good, okay? I personally like the kube context tool, which is the kubectx. Very handy tool. I don't like typing too much, so I kind of use that quite a bit as well. And then what you can do is you can install the watch command on Mac, which is not, for whatever reason, not installed by default. I use that quite a bit, and we have a lot of instructions which kind of walk through that. So once you have all this, and once you have the Kubernetes cluster access, okay, then you're going to use Helm to either install, in Kind or in Minikube. And if you don't have it installed already, we have some steps which talks about how you can install in Kind and Minikube, okay? And I will talk to you about that. One of the key things about any of these is that you want to make sure that the storage class is compatible, with what the operator uses, right? So you want to do the kubectl get storage classes, and you should see something like this, where it's like a wait for first consumer, okay? If you don't have a wait for first consumer, then what we recommend is we recommend you install, this particular Rancher, extension, which basically does the local path provisioning. Okay, and you'll see an output which kind of looks like this. And then if you do a get storage classes again, Now what you would do is you'll see, wait for first consumer. I think the steps are pretty much the same. Okay, so let me go ahead and try to do an install, all right? I'm already obviously done an install. First thing you want to do is do this kubectl, okay? And config get context, right? So this will give you all the context, okay? So if you're running into some kind of issues, you may want to check if you have, like for example, so you can also do this kubeconfig, right? Where you can point, a particular config file. So typically what I do is I make sure that, kubeconfig is set to nothing. Okay, and then what I can do is I make sure I'm running the right context because I have so many of those running. So this is a, I have, as you can see, I have a Docker desktop, I have K8ssandra, I have Kind, and then I have Minikube. I've tried it on pretty much all of these. And the nice thing again about Kubernetes, Helm, and all that is it's exactly the same, right? And all that I'm going to do is I'm going to cut and paste, from the command line window and just kind of walk through the steps. And when I'm walking through the steps, I'm going to, kind of try to understand what is happening under the hood. So that's kind of let's kind of walk through this. So the first thing I'm going to do is I'm, just make sure that this is up and running, right? So you can see I have something called as KSR, okay? And you'll see here, it's running a K3s cluster. It's 3 nodes. It's been running for about, like 9 days. And it's running the 1.20.2 version, whatever, right? I don't care too much about that. All that I'm going to do is I'm just going to say helm, and I'm going to say install, okay? So the first thing I'm going to do is I'm going to say install traffic on the, on the particular cluster. Okay, obviously this is going to come back because I think I may have installed this already, but it doesn't matter. Okay, so essentially what Helm is going to do, okay, and I'll go back to installing it. Okay, so once you have the local setup, okay, if you want to do the CVO, then what you're going to do is you're going to follow the steps for CVO, and it kind of walks you through that. It talks about how you can create an account and then get an API key, install the CVO CLI, add the API. I'm having trouble hearing you. Add the API key, ignore that, that's my watch. And then, you make that current, and then you create a cluster. And once you have the cluster created, which is really what I'm using, then you merge it into your configuration file. And if you do a config use context, it'll use the right context, and then you can, kind of look at what the cluster is. And then now, once you've done this, you can do this CVO Kubernetes show Cassandra, okay? I'm going to show that just for, so instead of K8ssandra, I'm using a different cluster here. Okay, and hopefully this should work. Okay, so you can see here, this is my cluster. It's running in Frankfurt. Okay, and it has an ID, it has an API endpoint, it has a DNSA record, which is all things that I'm using, and you'll see that, in a little bit. Okay, so how do I go about installing it? It's pretty straightforward. It's in the slides, but it's also in the instructions. All that you're going to do is you're going to add the repo, which is the K8ssandra Helm charts, which is available in helm.k8ssandra.io. You just add it to your Helm chart, Helm repositories. You do a Helm repo update, and then you do a Helm install K8ssandra. After you've done traffic, you're going to install K8ssandra in this following way. The only thing that's going to change is you're going to specify a different file, okay? And that file, otherwise, what's going to happen is it's going to take the default values, which may not work for every instance, right? We customize it for example, if you're doing a production cloud, then what we do, and you'll see that later in action, you have 3 instances of that so that it's, if something goes down, it's still available, right? Because the other 2 can serve it. So there are different options. But, again, if you go to K8ssandra.io and look through the docs, it kind of walks through all that. But our workshop instructions also kind of deal with that and kind of talk about how we can do that, okay? So let me go ahead and install. And again, I've done this before, so it's probably not going to be too interesting, tremendously interesting. But really, it takes a couple of minutes to install, and maybe about 6 more minutes, for everything to be up and running, including all the components, and then you're good to go. Okay. So how do I install this? Again, the same command, right? So install, so use this for local and CVO installs, right? All that I'm going to do is I'm going to say Helm install. I'm going to use the same repository, the K8ssandra repository, which I already added, and basically use the the K8ssandra component to be installed, and I'm going to call it as K8ssandra, and I'm going to specify the values in K8ssandra local cvo.yaml. Okay. So let's go ahead and do this anyway, even though I know I've done this already. Okay, so that's fine. We can ignore that. Not a big deal. So now if I go back to and take a look at what this is. Okay, you can see here there are a couple of these things that I'm using. The K8ssandra local cvo.yaml, or if you look at your install, you'll have a K8ssandra.yaml that you're going to use. Okay. So let's look at this briefly, okay? So you can see here what version of Cassandra you're using, you're installing, right? And then you have different resources that are listed here. And this is the data center that we'll kind of access as we look at, the different components. We have Grafana installed, we have Stargate, and we'll look at all this in a few slides. But essentially, the idea behind Stargate is it provides a unifying API to be able to access. This is more from a developer perspective. We're going to install an application called Pet Clinic, which is essentially derived from a sample app called from Spring. And using that, we can actually access the data on the backend by using the Stargate APIs. There are a number of ways of accessing it. You can do GraphQL, which is really cool, but you can also do REST. You can also do SQL. So it's basically a unifying API, this YAML file kind of does a little bit of that, or like I said, customizes it. Once you're installed it, you should see something like this. Okay, if you just do a kubectl get parts. Okay, you will see that most of these are running, right? So here's my CAS operator. We will walk through all of this. Traffic is already running. Grafana is running. Traffic is running. There is Cube. There is Reaper. We're going to talk about all that. And I've already installed Pet Clinic. So when I go to that particular exercise, I'll delete it and reinstall it. But you also have Stargate and a bunch of other components, okay? So maybe what we should do at this point, Alex, is should we take a pause and see if everybody is kind of up to speed? Or should I just go through this?
We can, for sure, but I wouldn't be focused so much on the pace because anyway, our training instances are stay available for some time after the workshop. And you can always catch up later and watch the recording, so we will be good. All
right.
Yeah. So yeah, we can make a little pause here for a moment.
Yeah, let's take a pause for a moment. Any questions that we can? I'd be happy to take a look.
Let me
stop sharing for a little bit and then come back.
Where is the YAML file you mentioned? Values file. It's in the repo for the repository. So github.com/work K8ssandra/workshop. If you get some deprecation warnings, blah, 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 port security policy is deprecated, it's completely fine. Just ignore it.
Yeah, good point. So all the files are available in this particular directory. I just put it on chat, github.com, K8ssandra workshop.
Yep, and yes, you are getting the recording. That is for sure. Oh, thank you for pasting the link. Yeah, that is good.
So Atit Shetty asked a question. I'm getting an error while installing Helm. I feel like if you're doing this on Civo, probably, then what might have happened is that you may have installed without traffic. If you look at the Civo install, let me go back to that. We basically make sure that we install it without Civo. Okay, so you can see here without traffic, and maybe that's the reason why it may be happening. So what you want to do is you want to specify this -r traffic so that it's not installed by default. So maybe that's what's happening. But Atit, if you want to put a little bit more information on where this is happening, we can help you. All right.
Yep. Or maybe it is running already, simply because if port is allocated already, then maybe it's just running and you are trying to install it again. That also can be the point. Okay. So
I think there are questions about how do we access the DataStax provided instance. Alex, maybe you can help with that.
Easiest way here to go with Civo, exactly as described into the documentation workshop. And if workshop is done and some time has gone and Civo generous offer is not available anymore, you can contact me in person in LinkedIn or via email, and I will spawn a training instance for you. If you wait for a moment, I will send you the link to contact me. But please, I won't be able to dispatch you. Yes, I won't be able to dispatch you a training instance right now, only after this training is done, because I have other things to do. And link is in this Zoom chat. Good. So if you will need a training instance later, then you can catch me. Good. And as Raghavan said very right, you can create your own cluster with Google Kubernetes engine or Amazon Web Services or Azure and whatever you prefer. That's also perfectly fine.
So the persistent volume claims, just make sure you've installed Rancher extension. I kind of walked through that, but make sure that that's happening. So what I would do is run this particular command, which is get storage classes. Okay, kubectl get storage classes. Okay, and then if that run this anyway. Okay, the kubectl apply and install the Rancher extension. Okay, so that may be what is happening to who's that? Peter Zhu. He did. Okay. 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 So what you can do is one of the things you can do is you can just go ahead and Helm delete K8ssandra. So I'm going to put that command here. If you need to reinstall, you can just say Helm delete K8ssandra and then install it again. Okay. So, there may be some times when you may have to kind of reboot, so to say. Then what you can do is you can just try the Helm upgrade, and instead of install, the install command that you have, just put the upgrade in there, and that should fix things for the most part. Again, you don't have to do that, but this is again just for instruction, and it might actually be useful for you to try that out. Okay. So what you can do is you can just do a Helm upgrade and the exact same command, and you can get the cluster back to kind of the initial state, so to say. I have only one laptop. It seems that I should have set up another screen to follow. No, you can just bring up multiple command line windows. So it should be pretty straightforward. Yeah. Yeah, like Jeff says, for production, we don't really recommend you using port forward. You want proper ingress, but for a workshop like this, I think it's just perfectly fine to be able to do port forwarding, because in effect, that's exactly what you're doing. And I'll show that as well, when we are working with the data, okay? Right. So port forwarding, I think, kind of gives you a little bit of under the hood view as well. So I think that's good. So let me continue with the components, and then we can take a pause again. Is that good, Alex? Yeah.
Yes, all good.
Yeah. All right. Hopefully you can see my screen now. Essentially what K8ssandra does, it kind of straddles the data part and the infrastructure part, because Kubernetes by itself is not enough, right? So, that's why we came up with this concept of Cass operator and then refined it further to come up with the K8ssandra operator, right? And what that does is, like, for example, you can set node affinity. I think one of you use, Adit, I think is using the Google Cloud, right? GKE. And maybe what you're, you have multiple zones, multiple availability zones, and you may want pods to be nicely distributed across those zones, so you can set affinity for the different data centers and things like that. And that's possible, and that's exactly the value that the K8ssandra operator or the Cass operator is going to provide. And there are a bunch of other things it does as well, that you don't need to worry about. But it also, takes care of the data aspect, which is why you've come here, right? You want to install a Cassandra database. You want to be able to access it using Stargate. So what it does is it kind of straddles the two and makes it very easy to access the cluster that you just created, either using Stargate or maybe even just using SQL. SQL, as we'll talk in a moment, is the Cassandra query language. So really what K8ssandra is really a scalable cloud native database managed via the Cass operator, which is going to be replaced by the K8ssandra operator. It is a data gateway providing the REST, GraphQL, and document APIs. It's a unifying API. It's available via Stargate. You can use any ingress really, but we document quite a few cases using Trafi. And again, for the purposes of today, for the exercise, for the workshop today, I think you don't even need to set up ingress, except for one exercise where it may be required. Especially if you're using a CVO instance, then it might be required. But it works with different ingresses, and it kind of and that's again the nice thing about Kubernetes is that you kind of rely on other components and make it work on whatever infrastructure that you're going to use. Reaper, we have a exercise for this, which is essentially a bunch of utilities for repair and backup. Of course, nothing is complete without monitoring, right? Observability has become a big aspect in all of these microservice-based approach. Very critical, and Prometheus and Grafana is one of the first exercises that Alex is going to talk to you about, right? And all of these again is packaged and delivered by Helm charts. If you're really a Helm geek, or you want to know a little bit more about this, we have subcharts and you can kind of look through this. All of these are available in GitHub as well. We would ideally like you guys to kind of help us by at least putting some pull requests, or maybe even helping us come up with these Helm charts as well. So typically what operators do is just Helm install, Helm upgrade, or Helm delete, whatever, as the case may be, right? And what it does is it's pointed to a Kubernetes cluster, which is what is the context, right? And what it does is it installs all of these components, okay? And then how do you get access to it is through an ingress, right? In a typical production environment, that's exactly what you do. You don't really worry too much about how to access this Stargate directly, but what you're going to do is you're going to use this via Trafi. And again, for today, we might be doing port forwarding, but if you substitute the port forwarding with the ingress, that's exactly what you see in this picture. Okay. And again, operators will have access to some of these components directly as well. As a developer, I probably don't care about many of these, but it all depends on kind of what hat you're going to wear, right? As an operator, as a developer, as an operator, I'm interested probably in the right side of this, and as a developer, I'm interested more in kind of the how do I get the data access and so on. We also have a way in which we can do backup and restore in a variety of clouds, and we leverage what is referred as Minio, and the exercises actually walk through that, which is a simple object storage based around Amazon S3, which is available on multiple clouds or even on local infrastructure. Okay, this is kind of putting that same thing in a slightly different picture, and these are all the port forwardings that you're going to set up. The blue dots that you're going to see. To make sure that you can have access to all of these different components, okay? And the workshop instructions are going to walk through which ports you need to forward and so on. Again, in a typical production environment, you're not going to worry about that, but because you're going to do set up the ingress. It leverages the secrets. Let me go back. Sorry. It leverages secrets, and that's kind of how it's done in kind of a secure fashion. And we'll see how we create some secrets. You'll walk through the instructions. So there's really a whole lot of things that are coming together. And the nice thing about K8ssandra when I started using this is I myself learned a lot about Kubernetes that I did not know before. It talks about how these different components are installed, what are CIDs, and how I don't need to worry. All that I'm going to do as a user or as a system administrator is just going to issue the helm install command. Or if I am a developer, all that I'm going to do is just install the YAML file for the application, and I'm up and going, right? So makes it very easy. Is there anything else that I missed, Alex? Is this good?
I think we are good. Yes.
All right. So with that, you want to take over with monitoring?
Give me a second to check. Right. Could you please, meanwhile, check chat for the questions?
Sure. I'm going to check that. I'm going to stop sharing. So Seema Amwad asked the question, I am not able to open traffic local cword.yaml. That's in the workshop directory, and that's where you get started. So maybe I'll repeat that again, the instructions, okay? So if you don't mind, I'll do the screen share again, and we want people to start using it, right? So essentially, so what you're going to do is you're going to click on this link, right? And it has this particular local CVO. Okay, so either you can download that, but ideally what I would do is just download this, either git clone it or download the zip file, or there are a number of different ways of kind of getting this YAML file. Okay, but all of these is set up in here. Okay, and you can start using it. Okay. I don't think I screen shared it. So let me repeat that again for the benefit of.
That happens, no worries.
Yes. Yeah. So essentially what you're going to do is you're going to click on that link, and that will bring you to this particular page. And you will see here, there is a K8ssandra local cword.yaml. And you can either git clone the whole directory, the whole repository, sorry. Or what you can do is you can download a zip file if it's really completely up to you how you want to do that. And then after that, just open the labs in Wiki. Okay, so just click on this particular link, and now it will walk you through the different steps. Okay, so we did the first step. Okay, and we did the local setup and all that, right? And then we can look at how to kind of do this in a Kubernetes the appropriate Kubernetes clusters. For example, for local CO installs, what you have to do is you have to set up this port forwarding, okay, as you can see here, okay? And you will see, I will do that as well. So all that you need to do is just do this, right? Now, if you look at the jobs, you'll see that, it's running this port forwarding. And next, all that I'm going to do is just click on this, right? So really all that you're going to do is just follow the instructions here, and you'll be directed to traffic, okay? So once you see traffic, okay, then you can click, you can click around and kind of look around. You can see here, I have set up some paths, which are really ingresses and so on. So all of these are in the instructions, but the first place you want to get started, is, let me stop sharing the screen, is really start with that workshop directory, okay? And let me know which, if you have any issues after that. All right. Alex, it's all yours. Should we again give people a little bit of time?
Yes, I believe we can give people a little bit of time, and I
know that one person, Ram, is using it on Windows. I'm sorry, we don't really have the time to kind of go through the windows. Yeah, we have some recommendations. What you can do is you can use Gitpod, and with Gitpod you get a Linux and an IDE, a Linux command line. So if you don't have access to the Linux tools, if you don't have access to kubectl tools, it's easier to install it with Gitpod. But we really don't have time to help you with the Windows aspect. Sorry.
Yes, and if you take a look, if it doesn't work out how you want it to work today, then don't worry, contact me, and I will create a Linux virtual machine for you in the cloud. So you still will be able to do all the exercises with or without Linux or Android or FreeBSD or whatever you prefer. We have you covered, okay? So that should be quite easy. I hope so. And good. So
there was a question about what do I have to install Helm? Yes, the local installs kind of walk through that. Step 6 of the local setup kind of walks through that. Please install it with depending on what environment you're in. All right. So if you get a Helm and you cannot do anything after that, you obviously have to install Helm. All right.
Yes, Helm is a package manager. If you haven't met that before, Helm is kinda a package manager for Kubernetes. It's technically this name is wrong. Helm is not package manager, right? But it works very close to the idea how apt or yum or whatever package manager you are using works. Basically, the idea is going to be exactly the same.
So should we try to get a thumbs up from people who have already set up K8ssandra?
Yes, please. That definitely makes sense.
Anna, thank you. Thank you for the immediate response. Very cool. Nice. The competition is not over yet. We will come to that later, but let's focus on getting the K8ssandra cluster going first. Perfect. If you have any other questions, feel free to put it in chat or, Discord chat actually is going to keep a record, and there are a lot more people helping there as well. So there was a question about K8ssandra Helm chart. How does it differ from using Kudo? I myself haven't used Kudo, so I don't know the answer to that. Anybody else? No.
Which technology is mentioned? Sorry.
Kudo. Kudo.
Sorry. Frankly speaking, this world of Kubernetes really reminds me of a world of front end in the very last few years when new technologies was spawned, get to the top of the world, and then were completely abandoned and forgotten within 1 year. So no, sorry, we don't have these kudos.
So there are a couple of experts there, right? Kubernetes experts. So maybe you can add, what Kudo is and how it differs from how.
Yeah, I see it mentioned in the chat by Lewis. Thank you. I will take a look. That's interesting. And question from Pavan Kumar. How do I use cloud instance? What is offered by you people? So how do you use it? You use it accordingly to the installation instructions you have in GitHub. And how do you get it? Is I will again paste the link to my HTTPS. I will paste the link again to myself on LinkedIn, so you can catch me after the workshop. Good. So
yes,
looks like
good question by Aman. Don't forget the trailing slash and dashboard. Then it will say give a incorrect path. Okay, so that's great. Thank you, Aman.
Okay. Okay, so maybe you can go on and show Grafana and Prometheus part, because I believe a lot of people are ready to follow along already.
Okay, you want me to do it?
Okay, no, I can do it actually as well. I'm just not sure if it is ready at this site. Was okay, Cassandra overview. No data so far. I'm not sure if my Cassandra has started already. So I have empty Grafana and Prometheus at this moment, which is a bit not enough to show.
Sure.
Which is weird because Prometheus is running. So yeah, maybe you can show it. Oh no, it's starting. I hope so. Looks like.
Let me know if you want me to.
Yeah, I believe you better start, because I'm not perfectly sure if it will work. Go for it. Yeah, so you better start.
Okay. So what I'm going to do is I'm just going to follow the instructions. So let me keep my fingers crossed and hope that it's going to work. Okay. So let's go with sharing my screen. Okay. And again, the first thing I do, no matter what, is I make sure that I'm running the right context, because that's the first thing you want to check. So I am running the KSR, which I know is my CIVO cluster, right? And what I'm going to do is I'm going to make sure the pods are up and running, right? So just make sure that it's all running, right? So you can see all of them are running, which is kind of cool. Okay. So then what I'm going to do is just go into the instructions which talk about that. Okay. So I'm going to open that. This is exactly what is on the wiki, because I just checked it in, right? And what exercise are we in? We are monitoring Cassandra, right? So I am a local CIVO install. So all that I'm going to do is I'm going to set up the port forward, right? So I'm going to set up all these three, right? And set up port forwarding. Pretty straightforward.
Sorry,
right?
I'm laughing because the very moment I told you, okay, go on, it started to visualize the data on my site.
Perfect. We can show that also, because that will give a difference between local install and a VM generated install.
Right.
Right. So let me finish this, and then you can.
Yeah, of course.
Okay. So I think this is fantastic. So now what we're going to do is use the links 9292 for Prometheus, because if you go back and look, if you just do the background jobs that are created, you can see here, Grafana is sitting at 9191, Prometheus is 9292, and Reaper, which we're going to see in the last exercise, is 9393. Okay, so all that I'm going to do is I'm going to access one of these, right? So let me go to my edge device, okay, and I'm going to do localhost 9191. That's it, as simple as that, and hopefully this is going to work, right? So this is the login, and it will let me log in. Okay, there is Grafana coming up. Okay, cool. Okay, and I think admin. The default that we have set up is admin and admin. Okay, so it asks me again because it's the default. So let me put it in anyway. I don't care. Okay. And I'm good to go, right? Again, thankfully I'm not an operator because, I violate all this rules for passwords and all that. But what you're going to do is you're going to walk through this, right? You look at the Cassandra overview. This will give you a view of the dashboard. What are the recent throughputs? What is the read-write distribution? How many nodes are in there? What is the disk space usage? A whole bunch of stuff, right? So you can kind of look through all of these. And then, if you go back to here, okay, I don't care about this dashboard because one of the nice things about Grafana is that it allows you to create customized dashboards. Okay, so we just saw the Cassandra. You can look at Stargate. How many HTTP requests per second? Nothing really right now, right? Because nothing has happened, and you can kind of walk through this. Okay, so that kind of gives you an idea of how to use Prometheus, right? Or Grafana, sorry. And I did 91. So if I do 92. Okay, you can execute this different instructions.
You can select any metric and see what's the current status and see what's the data you have on that.
Exactly. So you can kind of there are some examples of what to use here as well. Or if you are really interested, you can go to K8ssandra.io. And I'll kind of walk through that. If you look at this. K8ssandra.io and just go through the docs, it'll kind of walk through what you do from a SRE perspective, okay? And this is exactly what I did, 91, 92, okay? You configure the port forwarding, and then what you're gonna do is you execute this particular, so you click on 92 and verify these things are running. And then what you're going to do is you choose the target and verify that these particular things are working. Okay, so all that you're going to do is you're going to follow the instructions. So this is kind of the local install. So what Alex is going to now show you is the DataStax provided VM, which is actually running a VM with a local install of kind, but it's on a network, which makes it a little bit interesting. So again, Kubernetes gives you different combinations. We are not going to be able to cover all of them because we just don't have the time, but at least we'll give you a flavor of that.
Yep. I'm not really sure if, I can to show it, but I'm not really sure if we have to do it because it will, for the end user, let's say it will look the same. I have Grafana running on my cloud instance as a part of the story height video panel. Yep, I have Grafana running as a part of my cloud installation, and idea is the same. We have Prometheus, and Prometheus traditionally use it as a storage place for metrics, for monitoring purposes. So that must be familiar for you if you already working with Kubernetes deployments. If you don't, it may deserve your interest. And it collects a lot of metrics from different points, from different metrics. And you see, as you see here, metrics collector for Apache Cassandra is the tool we use to get data from Cassandra and put it to Prometheus and to Grafana. And I can execute the statement. I see, okay, there is some data. We receive some information from our nodes. But if we want to see the graphs, then it's much better to go to Grafana. And important point I want to highlight here, Grafana is installed as a part of our K8ssandra deployment. So if you go for kubectl get pods, you will see here Grafana running as K8ssandra Grafana, blah, 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 blah. And you know what? Batteries are included but swappable. If you already have your own Grafana deployment, you, of course, don't have to enable and install our Grafana. You can just connect it to the existing K8ssandra deployment, which won't have Grafana in this case, as you configure that. But what matters, it's not enough just to connect MC metrics collector for Apache Cassandra to Prometheus and Prometheus to Grafana. You have to understand what to visualize. And our deployment of Grafana is, of course, have a great set of dashboards, ready panels and dashboards for them. So we can go for cluster condensed and see their particular status and particular views over time. And actually, that's a very smart thing. So you can group it by cluster, by data center, by rack, and even by host. The only point is what at the moment it's a cluster of a single data center, of a single rack, of a single host. So information won't vary, but in your production deployment, of course, it will be different. So we can go for a smaller rate and we can go for smaller rates. We can filter by data centers and racks. We can even filter by key spaces and find the difference and understand what's going on. We can go up to host specific deployments. We can specify which percentile we are interested in this moment and get different information. And also that's a Cassandra cluster condensed overview. So it makes the general understanding of what's going on, the compaction, latencies, coordinators, and so on. And of course, there are some more dashboards. So system and node metrics. This is one quite a traditional. That's to understand the server states. So you see Cassandra or not Cassandra, you have to understand CPU consumption, memory consumption, disk space consumption, which is incredibly important, especially with Cassandra, and so on and so forth. And finally, we can go for the overview on some more specific K8ssandra nodes to focus on the read latencies, request counts, and so on and so forth.
So one question, Alex, there's a great question here. How can we connect our own Prometheus or Grafana instances to K8ssandra instance? So in other words, can we take our K8ssandra and push it to this instance that they are monitoring in a kind of in a centralized place, right?
Okay, so if you use K8ssandra with monitoring enabled, I mean K8ssandra monitoring enabled, when it's all out of the box. So literally, let's take a look at the command what deployed all these beauty. So let me clear it a little bit. And command what installed it was just helm install K8ssandra with some values as Rakhavan already has shown you. So if we go for K8ssandra.yaml, you will see everything what is enabled here. Kube Prometheus stack, blah, 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 blah. Stargate, Reaper, Cassandra. So everything was configured here. And then I just go for Helm install and it works out of the box, including setting data transfer, metrics, dashboards, and variables, and Prometheus, and everything. So you have all of that running off the box. I didn't do anything to get to this point. If you already have your Grafana and Prometheus running somewhere and you want to make it for our Cassandra, K8ssandra, so you want enable K8ssandra built-in, as said, batteries are included but swappable, so you can completely configure it on with K8ssandra to work with your own Prometheus deployment. and with your own Grafana deployment. That's explain it in details in K8ssandra documentation. I don't want to go too deep into that because it's already a little bit specific use case. So we better proceed.
So again, let's remind everyone that, Discord is really the best way to get, support for this, because I think like you, maybe other attendees will probably have the same questions as well. And, Discord is probably the best place to get more support. I know we are up to 2 hours right now already, but I think
and we have some more time.
Once we are created, I think we are these exercises we can run through pretty fast. Okay.
Yeah, right. So we can go we discussed monitoring already, and we discussed monitoring already. So we can go to high availability step, right?
Yes.
I'm going to proceed to high availability step. So take a look. Cassandra replicates data over multiple nodes. That means what in any moment of a time, with a single data center replication factor free, you are going to have at least 3 copies of your data. That means what if one server is down, you will still have your database operational and answering your questions. Replication is a very powerful mechanism. Meanwhile, if you write data and one of the servers was down at this moment, that means what with single data center replication factor free, 2 servers will be updated and third one won't be because it was down during the write. You understand the situation, I believe. 3 servers responsible for your data, 1 is down, you made an insert adding new customer, for example, or making an whatever your customer makes an order at your site, you have now new instance created, new rows, but deliver it only to 2 servers out of 3. 1 was down and it was unavailable. Now, don't worry, don't be scared, because first of all, as said, Cassandra is very smart and Cassandra is able to handle of this situation at the self-healing capability. Self-healing means what? Server will recover and information will be recovered and delivered to this server completely without your participation. And that is amazing. Just like that really is amazing. What is the mechanism behind that? Let's take a look. We have 3 servers responsible for the data and 1 server who got the request. Don't forget, Cassandra is decentralized, so we can deliver, you can reach with your queries any of your servers and it will take care of the rest of the things and you will be good. It doesn't matter if it's that's the replica server for partition 59 or it isn't, doesn't matter. So then this query coordinator sees what there is no confirmation what was data was stored at the failed server. That's completely fine. It will store and persist so-called hinted handoff. Hinted handoff is the first layer of Cassandra's defense versus cross-node inconsistency. What happens then? Then the server will be recovered. It will announce like, okay, guys, I'm back online. What's going on? What did I miss anything? And the one who stored this hinted handoff will send it to the failed server, recovered server. Okay, that's what you've missed. And again, as I said, that's executed completely automatically. So you don't have to do anything in order to protect the situation from this. So that's the story. That's the main story behind this. So we can show recovering from a failed node. I'm only thinking if we should, yeah, let's recover from a failed node in the simple way. And that's not for me relevant. Okay, good. Recovering from a failed node. Okay, yes, finally. So I will do it using my cluster in the cloud, and I will do it following the steps we have for this installation. Recovering from a failed node. With K8ssandra, recovering from a failed node is very easy because K8ssandra takes care of your operations. It's fully automated, and it will be like very simple one. First, I'm going to get the list of the pods. So let me clear that and let me get the list of the pods. So you've seen that already. We have here the main pod for us is K8ssandra DC1 default stateful set 0. It's the pod, it's the Cassandra node number 1. If they get to the, there is my command. Was here. I want to check the status of my cluster, and looks like it's somehow lost. So okay, I will give this command again. Not a big problem. Right, I need to get the password, and I will connect to my Cassandra node. That is my password, and I will, oops, wrong button. I will ask for this status. Okay, but I have to replace the password, of course. So what's my password? Good. Okay, so nice. Most of you must be not familiar with Node tool because most of you have no prior experience with Cassandra. I will help you. So we have here information about current node. I'm just executed command node tool status. It looks a little bit wider because first I have to go for kubectl exec, when I have to specify which pod I'm addressing and which container in this pod I'm addressing, and then give username and password. But what really matters here is node tool status. So, and here is my status. I have data, I'm in data center DC1, data center 1. I have one node. And the most important here is UN, like United Nations, but it's actually up and normal. So U means up and N means normal. It means it has joined a cluster and it's all good. So far we have cluster of one node, but soon we will fix that. Now, what's going on to happen next? Recovering from a failed node. How it works in K8ssandra. I'm going to go and destroy my stateful set, and no, although instruction suggests me to use grace period 5, I want to be cruel on that, and I'm going to skip grace period, and I'm just going for kubectl delete pod K8ssandra DC1 default stateful set 0. It's exactly the server you are seeing here, but more Kubernetes name of this node, right? And pod was just being brutally deleted. Like it's not a normal. So in general, if you run a K8ssandra cluster, please don't do that because watch you will notice what it's not exactly the idea. Oh, okay, I was too late. I should have executed kubectl watch pods a bit sooner. So the general idea is, if you run your production cluster, don't kill it like I do. If you want to decommission a node, you don't do it with delete pod, okay? You, instead of that, decrease the nodes count and at the K8ssandra YAML file, mostly probably. But what matters, as soon as the pod was destroyed brutally, then K8ssandra immediately notices what the pod was destroyed, and you know what? It creates it again. It's a fresh new pod, but because it was not just a random pod, but pod what was a part of a stateful set, it's perfectly fine. And now we see how K8ssandra starts it, and yay, that is running. And basically, we just seen how
it's looking at the current state and the desired state, and it's matching it, right? And that's really not anything unique of our operator. It's exactly what Kubernetes does, which is really referred to as self-healing, right? So, yeah.
Yes. So there are two important points. And again, we see what our node is up in normal state. Now, there are two layers of healing. First healing, stateful set spots, it is taken care by K8ssandra, by Cassandra, by Kubernetes in the very end. But in the case of the data, so what data will not be missing, it will be taken care of by Cassandra. So you see, it's a teamwork, and teamwork makes dream work. We have here Cassandra and Kubernetes seamlessly working together and taking care of first. As soon as pod is crashed, it will be restarted. And if in case some data may be lost, it will be kept by the query coordinators and then dispatched later to the failed states, to the failed nodes, recovered nodes, better to say. Don't blame the failed nodes. That's mostly probably not their fault. That's usually power outage or something like that. Good. And let me think. I believe we just did with this part. And we can proceed to next part. And what was the next part?
I think this is the data and API access.
Data API access. Okay, so I will switch to your screen. So, I mean, you will start sharing, right?
Yes. Thank you.
Okay, good. So you can go.
Okay. So let's start looking at data and API access with Stargate. Okay. And we have a bunch of things here in exercise 4 and 5, but you can kind of go through them really quickly. And the idea is that, it needs to work with both, the dev side and the ops side, right? And the idea is that, it should be easier for SREs to set up developers to be able to use, the different APIs, whether I'm using document API or whether I'm using GraphQL or I'm just, doing SQL. I think there was a question.
I'm sorry. Are you sharing your screen? Because I cannot see it.
Yeah.
Oh yeah, now good. Thank you.
Thank you. Yeah, and the idea behind this particular slide is that it should be easy for both developers and system administrators to be able to do that. And Stargate provides a wonderful way of unifying these different APIs. It's basically a way in which you can access the data in different forms, kind of polymorphic access to data, if you will. And again, with microservices teams, each team will have their own strengths. So each team might prefer to do it in a different way. And Stargate actually allows access to that. The rationale behind developers is, there may be different query languages that you are kind of used to it. How do I kind of deal with it rather than kind of opening up all the ports? But what you're going to do is open up limited ports and just make Stargate as a unifying point or kind of a API gateway, if you will. Not quite API gateway, but that's the idea behind being able to use the different APIs, right? So there are a whole bunch of APIs that we're looking into. And one of the cool things that's coming, especially from a microservices perspective, is gRPC. gRPC is kind of the right way of doing it with microservices, because any of the other approaches, it's kind of an anti-pattern for microservices. And gRPC is coming pretty soon. If not already, right? And the nice thing again is that if you're using different versions of Cassandra, doesn't matter. Even DataStax Enterprise, they're all front-ended by Stargate, and all that you're going to do is you're going to funnel your request into Stargate. Stargate is going to do the right thing and give you back the response appropriately, okay? So with that said, let's look at some of these exercises. And again, all that I'm going to do is just follow the instructions very faithfully, okay? So let me go into the instructions. I think the first thing that's going to do that we're going to look into is installing a application called Pet Clinic, okay? And I'm going to open that. Okay. So let me see where I am. Before I go with Stargate, let me go with working with data. Okay, so I'm going to install this Pet Clinic, okay? So I'll make sure that this particular application is not installed. As always, just to be sure, I just do a kube context. Okay, make sure that I'm running, KSR. If anything, I just do the kube get nodes. And I know, this may seem like repetition, but I've been burnt several times by not doing this correctly, okay? I install it in the wrong cluster. I think it makes it easier, so let me go ahead and delete this if it's running. Okay, so what I'm going to do is instead of apply, I'm just going to delete this. Okay, and then I'm going to start again. I'm going to delete it, and it's all gone. Okay, so now I'm going to apply it. Right, and the beautiful part about this is that all the components that we're going to see here, the front end uses, and I'll look at the YAML file in a second when this is spinning up. Okay, and we'll just do, yeah, it's okay. All right, so what we have is a deployment, and it has a bunch of applications here: Pet Clinic front end and back end, right? And what it's doing is providing those secrets for Cassandra user and password to be able to access it. And then I look at listening ports and all that, which all happens under the hood. And that's the nice part about this is, just by using the YAML file, I'm able to stand up this application. Okay, then I have the backend. The backend is talking, with a particular port, which I really don't care because all that the backend is going to do is going to provide access to this front end. And once the front end is up and running, it's going to stand up a service, and that's kind of how I am going to access that. Okay, so very straightforward. Okay, if you see the instructions, it'll tell you, this is a CVO install, like I said. So I look at this particular IP address that's been created, right? And all that I'm going to do is I'm going to look into this particular address, and hopefully, if everything is working, the Spring Pet Clinic should start loading. So initially, what it's doing is Spring uses a concept of what is referred to as lazy loading. So it's not going to load, these classes unless it's required and it's going to be injected at runtime, right? So now what I'm going to do is I'm going to go into pet types, okay, and let me see. Just give me a second. It should come up. You can see veterinarians. Okay. Yeah, I'm not seeing that. Let me see what's going on here. Let me go back home. But you should be able to spin it up and see this up and running. And one of the nice things about this is I've also set it up for essentially what I've done is I've forwarded my domain to this. So if I just do a curl, ragsns.com, I believe that's what I should be able to see this as well. So if I just go to ragsns.com, that's all I need to have access to this particular application. Okay, so it's doing the right forwarding, okay, and it's bringing up the application, okay. And you can see the pet types here, right? And I can add the pet type, all right? I'm going to add a pet type of Alex as well. Okay. Or you can, go into look at all the veterinarians. And the nice thing is you can get access to this through SQL as well, as we'll see in a moment. Okay. So again, the next step is, we install the Spec Clinic. It's all up and running, okay? And to see it's up and running, again, very easy. All that we do is we just do the kubectl get pods. If I can spell it. Okay, so you'll see that, the Spring Pet Clinic is up and running, okay? It must be up and running somewhere in there, backend. There was a problem here, but the other, I'm not quite sure what happened here. I'll figure that out. But essentially, you saw that actually being deployed on Celo, okay? Okay, so for local installs, it's a little bit different. For Minikube, it's again a little bit different, but in principle, it's exactly what is outlined in this document. So the next thing we're going to do is we're going to set up the port forwarding. Okay, let's see if everything is running here. Looks like everything is running. Okay, and I'm going to run port forward this. Okay. Now what I'm going to do is I'm going to retrieve the super user password. Okay, because I really have access to all that, right? So I get the super user password. And then I get the super user user name and now the password. Okay, so I'm getting the password. So this is the password I'm going to use. Okay. So essentially, what I'm going to do is I'm going to use SQL on this particular K8ssandra cluster. Okay. Let me do this. Do it again. Right. And I'm going to put the password. And it's this, right? And hopefully, if everything works, we should be able to get SQL access to this. Okay. So there I am. Okay. So now, again, all that I'm going to do is I'm going to look at what are the different key spaces in here. Okay. I'm going to use the Spring Pet Clinic and I'm going to describe the tables. Okay.
Yep.
So,
and notice,
so this is a different database, different K8ssandra cluster. So you might see things a little bit different. But you kind of get the idea. What I'm going to do here is kind of look through the data and then exit the SQL shell. Okay.
I'm sorry, if you struggle to understand what that means, to define to what is described, what is the key space, why use Spring Pet Clinic, what is select all, blah, blah, blah. And if you don't understand what exactly going on here, it's completely fine. It's basic Cassandra query language operations.
Correct.
And if you don't know what's going on here, we do invite you to attend our Intro to Cassandra workshop, or at least watch the recording. It very much deserves your time. Absolutely.
Yeah, good point there. With that, let me move on to the next exercise too, because I don't think we have too much time here, right?
Right.
So the next time, the next exercise is really about using Stargate. Okay. So again, same principle, right? You access the Stargate by, essentially this is a REST-based call. You again plug in the K8ssandra username and the K8ssandra password. Okay. And what you're going to do is you're going to get back a token. Okay. So a token kind of looks like this: auth token and an access token. And then what you're going to do is you're going to use this access token to plug it in here. What is the Cassandra token in the HTTP header? And then you can access the same data with, using REST rather than with SQL that we showed, right? I mean, a lot of people may not be comfortable using SQL. They would rather use REST-based call and all that, the Stargate, what it does is it provides a Swagger interface for you, a REST interface to be able to walk through this. And like what Alex said, if you want to know a little bit more details about how to access these endpoints and so on, you can even create an AstroDB with free credits, and actually it provides you with a Swagger UI that you can call these endpoints. It will provide you with a token that you can use and so on, and walk through that. Okay. So that should be good enough, Alex. Anything you want to add?
Yes, I think so. I think we are good.
Yeah.
I think we can go to
scaling. Here are some of the examples, like for example, getting key spaces, inserting documents and so on, and the instructions kind of walk through all of that. If you're interested in doing GraphQL, we again have a workshop extensively focusing on that. Document API, it doesn't matter. You can do all of that as well.
Do you think we have a topic what is not covered by one of our workshops?
I don't.
I mean, like so. whatever we speak, we always okay. By the way, we have a dedicated workshop about that.
Exactly. Yeah, we don't have one. I can come up with one. I'm gonna do a Quarkus and Cassandra workshop in a couple of weeks. So I'm still working on it. But again, great for microservices. But you're right. We have so many workshops. You can definitely learn a lot from the workshops. And I'm gonna stop talking about our workshops, Alex.
Okay, so now you know what we did quite a lot. We deploy it, we monitor it, we discuss it, how it fails and starts automatically, how it recovers from problems automatically, but that's not enough. In the beginning, I told you what there are things like replication factor, and how can we have any kind of replication factor if we so far have only one node. Let's move on with that. First thing we have to take care of is understanding of the scaling. Here, understanding of a Cassandra scaling, primary, you have to get the 2 points, only 2. First, Cassandra scales elastically. Today you need 1 server. Well, that's not a Cassandra way, but you can go with that. Tomorrow you need 5 servers, perfectly fine. Next week you need 5 dozens. That works as well. And if in 1 year you will need 5,000, you will have, and you can have 5,000 of servers. That's what known as Cassandra elastic scaling. There are basically nearly no limitations on how big your cluster can be. And that's a very, very, very important point. But second thing you need to get is a linear scaling, because, okay, elastic scaling, just a simple concept. Elastic scaling means you can have more and more servers. As a result, you can have more and more velocity and volume and stay on top of the situation, even if you have now like billions of clients. But with a linear scaling, it's a little bit more advanced concept. So I know you are tired after 2.5 hours, but now please wake up and let's take a look on that. Linear scaling means what? There is no overhead or adding new nodes. And if it's not clear at the moment, let's take a look. Normally, with traditional relational databases especially, you can add more servers into the cluster, but they all always have the overhead. And they have also another problem, what some of them will be write-read, and some of them will be read-only replicas. Not in Cassandra. Cassandra is decentralized, elastic, linear for scaling. And you can write to any of the nodes. It still will be processed. But there is no overhead on adding new nodes. What's exactly that means? Let's take a look at the research was done not by DataStax, but by Netflix. Some years ago, Netflix did an incredible research on how benchmarking Cassandra scalability on over 1 million writes per second, 1 million of writes per second. That's quite a lot, ladies and gentlemen. So take a look. By the way, if you are not subscribed to Netflix Tech Blog, I do suggest you to subscribe. Personally, for me, it's one of the best sources of interesting articles about how does Netflix handle their workloads. So they had a Cassandra cluster in the beginning with approximately 50 servers, I believe something like 45 or about that. And adding more and more and more servers into these clusters. So basically going from 50 to 300. They meanwhile managed to get amount of client writes successfully written to more over than 1 million writes per second. And what's the main point of this research? That's not a surprise what Cassandra can handle millions and millions and millions of writes per second simultaneously. Just give it enough powerful servers, add them into the cluster, not a surprise. But that's the main thing here is this line is straight. So if you would add more servers, it will go again straight. It's a straight line and there is no overhead on adding new servers as long as your data model done right. And you know what, Rex? I'm going to say that again. We
do our workshops.
We have a workshop about data modeling for Cassandra. Yes, yeah. Right. So we have a free workshop for you to know how to build Cassandra data model done right, advanced data modeling for Cassandra. And what really matters is, take a look, this linear scale-up linearity is the shared responsibility. If you don't think what you do, just throw some data into the cluster, let it run, then you can get this linear scale up. You have to learn how to reach that first. And then as you do everything right, you will be good and your scaling will be linear. One point, you can make experiments when you are flying a Boeing in an airplane simulator, like Microsoft Flight Simulator. You can do whatever you want and you can try to do any tricks. And it's the same with Cassandra. Running it in your testing environment, you can do whatever you want. But if you're going to go to production, if you're going to have your real clients working with your real deployments, you know what to do. Yes, we have workshop for that. And even better, we have something better than the workshop. We have a full course for developers. We have full course for administrators, quite a long one at the academy.datastax.com. And they are free. They are sponsored by DataStax to you. So you can get your education and then later certification for Apache Cassandra. And that's really cool. So don't make a mistake. You can make tricks in Microsoft Flight Simulator, but don't go to production Cassandra cluster without proper education. It may be dangerous. So visit the academy.datastax.com first. And that is the exercise for scaling up and down, or actually considering time. I believe we will be scaling only up because it is very, very easy. And we just do not have to, way to do it is exactly the same. So we won't change a lot. So basic idea is for us to change the size of the cluster. And I will raise this size. We can do it with configuration files or using Helm upgrade command. But frankly speaking, I do recommend you to go with configuration files, infrastructure as a code and everything, and keep your config files in Git. So you will have versioning over your infrastructure and configuration. And that's the best approach to understand what's happened after the recent change. So let me switch to my browser. So, hey, there are you. Right. First thing I have to understand, hey, there are you. Yes, is what I want to understand current size of a cluster. If I will ask Helm, Helm to get manifest for K8ssandra, it will be huge. So it will take many screens because configuration of a cluster is actually quite big. And there are a lot of knobs and levers. But what matters for us is if I want to, hey, what's going on? Let me, oops, cancel. So that's not what I want. Reload site. But let's do this user. I'm using cloud instance, as you may remember. right. And give me a moment to log in. Good. By the way, if you have, of course, it was wrong password. So take a look. If you will use a cloud instance from me, not a Civo instance, and if you don't have experience with Linux, we have a lot of people who say what I'm typing password and nothing happens, something wrong with your instance. Mostly probably guys with no prior Linux experience. When you type your password, Linux doesn't show your password. It's completely fine. Now I'm pasting my password, enter, and I'm in. Okay, I have to reconnect. Oh my God, what was that? On the good side, you don't have to install anything with our cloud instance. You just need to use our cloud instance, and shell is in the browser. So everything is installed, Helm, kubectl scheme. Okay, good. So let me get back. First thing I'm going to do is not scaling. Yeah, but scaling up and down, right? I want to get the understanding of my current cluster. So I will get size for K8ssandra using Helm. And there is a plenty of sizes, but what matters for me is size 1. This one means what we have one and only one node running. We already know about that because, well, that's how it goes. And meanwhile, right, that's this scene. Oh, describe, of course. Describe. Yeah, so you see again quite a lot of information here about our data center. Now I'm going to change this data center. What matters for me is what I'm going to scale up, so we will have more servers located on different workers. So we will go for it. Idea is very simple. I will first change the configuration file. As I'm using cloud deployment, I will go with K8ssandra.yaml. So it's going to be quite easy. I will take, for example, K8ssandra YAML file. And here we have data centers DC1 and size 1 and Rex 1 with a name default, which is enough for us. I will go to 2, save it, and I will go for the upgrade command.
And
so
the nice
my
thing
command
is
will be
it's so it's so consistent, right? If you update any of the values, all that you're going to do is you're just going to do the Helm upgrade command, because what it's going to do is it's going to use the new values, right? And no matter whether you're doing the size or whether you're changing the names, things like that, it doesn't matter, right? Or setting heap size, all of them work pretty much the same.
Right. And so I go here. I go for Helm upgrade K8ssandra using configuration file K8ssandra YAML. And it will take a couple of seconds. And my next command will be watch get post. Where is it, by the way? Oh, okay. That is, here we go.
Right.
Okay, and we see what there are some changes. What matters for us is this one, K8ssandra DC1 default stateful set 1. So the first one is running already for half an hour, but the second one was just started. It's the new stateful set, which is being initialized at the moment. And it will have soon 2 containers running, 1 container for management API and 1 container for Cassandra per se. And we can take a look on what's going on at this point. So if I go for kubectl get nodes and get nodes, we have some workers here. And if I go for kubectl get pods -on, oh my God. What does the command to give this wide output? Yes.
So wide, yeah.
Right. Yep. Thank you. So notice an interesting thing. Take a look. Stateful set 0 runs on kind worker 3. Stateful set 1 runs on kind worker, just kind worker. That is not a coincidence, but intentional scheduling them as far from each other as possible. So in case of something goes wrong with one of the workers, others will stay available. So they are located on different workers on intention, of course.
And goes back to the high availability part that you were talking about, right? You know, you want to be...
Yeah, exactly.
Even if one rack fails, you're still going to be able to function reasonably well.
Yes. And we see what's going on with stateful set 1. It's in 1-on-2 management API starts faster than Cassandra. That's for a reason. It's much simpler than Cassandra node. But within some more seconds, we will have a stateful set of 2 servers running. And meanwhile, while it's being started, I will go to setup Cassandra part to take a look at the server status. So I will get my password. I will, I have password next. Oh, sorry, I have password. I will execute commands to get the status. But I have to update the password. Okay, so again, Kubernetes commands can be quite long, but the idea will be the same. Okay, it's done. I was too slow. I wanted to show how it starts up, but it's joined the cluster already. I was too slow. Okay, it's restarting. So we will see it soon. We could have seen it in joining state, but so it should be UJ up and joining, but I was too late. It's already joined. And we're restarting the second one. Hey, and I believe it will be there in a moment. So I don't want us to sit and wait for the node tool status. I believe we can go further while K8ssandra cluster is doing its job. What's going to be the next? Rex, what's going on?
So my suggestion is let's skip the backup restore because we really don't have time for that, and the repair.
Yep.
Right? And let's jump right into the multi-region. You know, if you do you have the video queued up and you think you can?
Yeah. Okay. You know what? Let's walk. Let's run through the slides quickly, yes. And that will be mostly enough. So just things
because
you need.
Yeah, you're right. You know, because all that we're doing is follow the instructions. So it's a good idea. So let's do that.
Yep. Right.
So let me
but
take the first part.
Okay, sure. Go on.
And the backup and the restore. Essentially, all that you're going to do is, again, kind of you can notice a trend here. You initially what you do is you set up Minio, you know, which is a way to have this S3 kind of layer on top of the different infrastructure, Kubernetes infrastructure you're going to use. And then you install a backup, which is going to take a backup and think of it like a snapshot, right? You know, that's exactly what you're doing. And you can do it on pretty much, you know, a number of different storage engines because, again, we are using something that works across those different engines. And how do you back it up, and then how do you restore? You again do a Helm upgrade, right? So you will see. So let me walk through the steps. Although I will not walk through the step, I will just kind of follow along with the instructions, right? So let me open this and look up backup. Okay. So you can see here what I do is initially start with adding Minio. Okay. So once I'm done with the Minio, then I add a Medusa, which is really a way to do backup, right? And it provides the secrets, and you have the access key ID, the access secret, and so on. And then you can kind of look at the secrets. And then what you're going to do is you're going to create a backup, right? So how do I do a backup is, so I've created some data, I've done this, exited this shell, and then I install the backup, the new backup. This is the name of the backup, right? And I monitor to make sure that it's done. Now I come back in, delete all the data, and then I'm going to restore it. How do I restore it? So I do the restore test, okay? And then I restore it from the name of the backup that I just created, right? So the backup name is backup1. And what is the Cassandra data center name? And that's pretty much all that you need to do. And when you, again, go back and look, you would have gone back to the original state that you were in before you deleted it, okay? So it makes it very easy to use. And again, kind of follows the same Helm philosophy, and be able to provide a unifying layer across these different clouds and different infrastructure that you're going to use. You might be sensing a common pattern here, right? So, okay. Do you want to touch repair?
Sorry,
Alex?
again?
Yeah.
Yes, repeat, please.
Do you want to do repair?
Yes, okay. I don't want to do repair, but I want to go through repair slides quickly.
Sure.
Okay. So I will present and I will catch the screen. Share this.
And I know that the multi-region demo is just about 7 minutes, so I think we'll be good with that.
Yep, good. So idea of a repair is very simple. Take a look. Then you know what hinted handoffs already are ready to protect your Cassandra cluster from cross-node inconsistency. That is great, but they have limited time to be applied. In the current configuration, it's by default 3 hours. So if node recovers within 3 hours, you will be good automatically. But what if it doesn't? First of all, you can, of course, raise this graceful period time on editing the configuration, but it's not really recommended, or at least we don't recommend to go too high in these numbers. Automagic self-healing is great, but there are some situations like if your node, for whatever reason, was down for 3 days. I mean, like shit happens sometimes, right? Can you imagine the amount of hinted handoffs to be streamed to this node? Like when you have like 1 million of writing operations per second? It's going to be tremendous. That's why this graceful time is set to 3 hours. And for some deployments, you actually want to decrease it, not increase it. But still, okay, if node was down for 3 hours and 1 second, how do we recover from this case? So there are different approaches. Some recommend to decommission the node and bring it back as new, which may be good choice. But the general idea, if some data wasn't recovered, is repair mechanism. Repair mechanism has multiple triggers. Sometimes you schedule a repair which will go and check for inconsistencies potentially. Sometimes repair is initiated automatically again when a query coordinator notices what some data received from some server was actually outdated. So again, there are multiple layers of defense and repairing mechanism initiation. Repairs is the method to keep data across Cassandra cluster in sync. And it's important to run repairs on the regular basis because on high clusters with a lot of writes, consistency may degrade over time if you don't have repairs. As Vinay Kumar Chella said, cloud database architect at Netflix, without repairs, your database is hopefully consistent. Not eventually, not fully, but hopefully. And that is the best statement I've ever heard about repairs. So yeah, without repairs, your database is hopefully consistent. So there are some repairs what will be initiated automatically, and some repairs you have to initiate on your own. I just want to show a general idea if it will work for me in a moment. Repair. Right. So with our cluster, K8ssandra, we have a tool installed by default, which is called Reaper. Reaper was originally developed by Spotify. That's not a mistake. Thanks, Spotify. Great job. And Reaper helps us to schedule and manage repairs. So in this case, I won't spend a lot of time in Reaper, but you can see what, okay, there is a Reaper. We can add a new schedule. We can choose the cluster and key space we want to repair, who will be an owner. Let's say Alex, what will be the start time and interval. Let's have it weekly, and I will add the schedule. And that schedule is active, but it will be executed at some point. So I want to run it right now. I run it right now, and repair run is in progress. So I can go to repairs and see what my repair is happening right now with 20 tables to cover. And it investigates token ranges step by step and sees if there is anything to repair. And if anything is wrong, then consistency will be recovered automatically. And that is great. So first segment is done, and we are going to go for second and third and so on and so forth. And we see what no fails were registered, which is, well, quite expected, of course. Reaper deserves its own quite a long description. Oh, second segment was done already. Thank you, Reaper. I just wanted to see what repair scheduling and things are also automated here and deliver it to you with K8ssandra, so you don't have to install anything for that. It's already there. That is the point. And there is an exercise to run repair. I just did that. You've seen I went to Reaper and started that. And there is a multi-region K8ssandra last demo. Before we go to the game, so you stayed with us for 3 hours, don't quit now. After this multi-region demo, we will go for the game and you will win some prizes. Only the best of the best, because you stayed with us for 3 hours learning a lot of new things. So, give me a moment.
So there are a couple of people who are asking me about, usually there is no persistent volume claims. You will have to install the appropriate storage class. I think somebody was able to get around Minikube by installing a earlier version of Kubernetes. If you can, please submit a PR and let us know if it doesn't work on the latest version, and we'll see what's going on there.
Right.
I'm just kind of looking through, any other. I know that some people had that consistency level 1 pop up every now and then. What you can do is you can either delete and try again, or kind of just do an upgrade, and it should fix it. Okay.
Okay, so I'm ready to go for the multi-region demo, which is one of the best, I believe.
Thank you.
Let's go.
Hello and welcome to this brief demo of Multiregion Cassandra based around K8ssandra, which is basically Cassandra on Kubernetes. As you already know, Cassandra is immune to the failures in fault zone and keeps on ticking. We are taking this one step further with multiple regions. This walkthrough or demo is based in GKE, but the idea, as with anything Kubernetes, that it's actually going to be multi-cloud. This will be a little bit forward-looking and is based on the idea of how the CAS Kubernetes operator is going to be replaced by the K8ssandra Kubernetes operator. but we also show how it's working today. There are a few details like networking, sharing secrets, etc., that need to be done manually. And I'll kind of walk through that as we go along. So the idea is really that the Cassandra seed nodes in the multiple regions are able to talk to each other via some networking magic. And really most clouds enable this with the concept of VPCs. So let's get into this a bit. The idea is that Cassandra is going to be spread over multiple regions and to make the install seamless. So to make this happen, we have a K8ssandra operator that essentially is going to install K8ssandra on multiple regions or multiple clusters in multiple regions, and then a way to talk to each other. So this slide talks about how the networking is enabled and how the K8ssandra operator enables the respective data centers to talk to each other or respective clusters to talk to each other. This slide kind of puts it all together, which talks about the K8ssandra operator and also the Cass operator, which is not going away and is still being used to install Cassandra on the respective clusters. So this is kind of the high-level overview of what we are going to see in action today. Remember, we don't have the K8ssandra operator yet, but we're going to leverage the Cass operator, and I'm going to show you some steps that I had to do manually to enable this to happen. So with that, let's dig in and let's look at the demo. So the first thing I'm going to do is look at the different clusters I have access to. And you can see here that I have two, Central one and West one. Both of them have K8ssandra installed on it. Okay, so let's do a quick check on the pods. Okay, and you'll see here the different components that are running here. Okay, so let's quickly switch to West. Okay, which is the other cluster, and kind of do the same command as well. Okay, we look at the different pods, and you can see here Prometheus, Stargate, and the data centers itself, which are running on the other cluster. Okay, so how did it, I enable this? Is let's take a quick look at the values.yaml file that I used in the install, and that kind of gives you an overview of how these respective data centers were installed. So you can see here, there are two data centers, and the critical part here is the seeds. So what I did was took the seeds from the first cluster and plugged it into the second cluster, and that's pretty much all that you need to do. So you can see here, DC1 is Central 1, and DC2 is West 1, and the two are able to talk to each other via these seeds. The networking is another aspect that we'll have to get into. So to look at the networking, let's look at the clusters again. Okay, and this is more of a console view. And this is the first cluster, right? And the most important thing here is that it's running on a particular network called RNS network, right? And if you dig into this a little further, okay, you can see here that actually is has access to the subnet that the other K8ssandra cluster is using. So essentially, that's how the two are able to talk to each other in one kind of a virtual network, so to say, right? So if I go back to my Kubernetes cluster, right, and look at the second cluster, okay, you can see that it's using that that same subnet and is on the same network as the first cluster, and that's how kind of the networking happens. And all of this is explained in one of the resources that I'm going to point to in a second. So that's it for the demo. One last thing that I probably want to show here is the data centers in action. So what I'm doing is I'm running the node tool, and hopefully, if everything is working right, you should see that they are running. So to do that, I first have to set my kube context. So I'm going to go back to I have to set it to central one. And now what I can do is I can run the same node tool. And like I said, if everything is working fine, you should see these two data centers up and running. So you can see here DC1 and DC2. DC1 is central one, and DC2 is west one. And they're basically talking through the seed nodes. So that's it for the demo. I just want to point to some of the resources. If you want to do it yourself, the blog kind of goes through more details. But if you're interested in a more general overview of K8ssandra, we have a workshop at KubeCon, but we also have some recordings that you can kind of look through. It's available on K8ssandra/workshop on GitHub. And then, of course, if you want more information on K8ssandra itself, including being able to install it on multiple clouds or being able to install it locally, you can go to K8ssandra.io. And with that said, thank you very much for watching this brief demo.
Okay.
I didn't realize that I'd gotten a haircut in the middle. So that's funny. Thanks everybody for pointing it out.
Yep. So that is cool because multi-region deployments are one of the most complex in relational database worlds, especially when you start to think of something like active-to-active deployments. And this question just simply doesn't exist in Cassandra world because it's always active-to-active. Great. So what comes next? I believe our attendees deserve to have some swag, some prizes. Yes. Okay. So we have almost 100 of participants after 3 hours. That is like a dream team. So let me switch.
Appreciate the patience. Thanks for taking the time.
Yeah, that is incredible.
So we will be ready for swag. Just get ready with your Menti stuff, right?
Right. And boom. So I'm sharing, and sharing is caring. And what matters now, you have to jump in to Menti. So don't forget, you go to menti.com and enter the code 42541711, or just scan the QR code I'm showing at the screen at this moment. But I hope you are already there. So once again, menti.com, enter the code 42541711. Easiest way to use Menti is just to open it on your mobile phone and answer the questions there while keeping your browser, your Zoom open, so you can see the bigger screen.
Don't look at Zoom because Zoom might be a little bit late, right? Zoom might be a little bit delayed. So just look at your mobile phone or your whatever device you're using.
Yes, yes. Speed of your response matters. So if you want to be in the best of the best leaderboard, so you better watch indeed Menti, but I don't think we will have a huge delay today. So let me see. I see what people are joining, and that makes me happy. Ladies and gentlemen, we are in the very end of the workshop, and there are many dozens of people ready to fight. That is great. Thank you for joining. I see 63. I'm a bit curious. There are all the others. Maybe they don't want to have any kind of prizes.
Just give it like
but I
maybe
will start.
15 seconds.
Okay. If you want to join, there is always an instruction. Go to menti.com and use code 42541711. If you answered our setup questions in the beginning, that will help you to use Menti. You already know Menti's interface, although it's not really complex. So 70. Give me 71. Give me 71 and we will start immediately.
I like it, Alex.
Oh, yeah, here we go.
All right, we're ready to go now. We are 72 now.
Okay. Let's go. So, ladies and gentlemen, answer fast to get more points. How many master nodes does Cassandra require? At least 3. At least 3 per data center. Enough to maintain consistency. Known, Cassandra is a masterless system.
Watch out. Alex is a tricky guy. He asks some tricky questions.
Yeah. I have some not really easy questions. And boom. It looks like some of you weren't really listening to us. Cassandra does not need any master nodes because they does not exist in Cassandra terminology. Cassandra is a decentralized system with no single point of failure, no master nodes. If you're familiar with peer-to-peer systems, that's the core principle of the Cassandra cluster. So right answer is known. Cassandra is a masterless system, not free per DC, no way enough to maintain consistency. So many people gave the right answer, but who was the fastest?
Fastest.
Yeah. Okay, Ati was the fastest.
Cool.
Cool. With 989 points, that's a very solid result. And Black on the second place with 30 points difference. That's not a lot. And then, hey, Cedric Lundven.
Cedric is doing well.
Employee.
Man.
Yes. Cedric, you are a DataStax employee and you're still on the third place. How is it possible? You have to be on the first one.
That's right.
Okay. So let's take a look. Question number 2. So answer fast to get more points. In Cassandra,
anybody can beat Cedric here?
Yeah, go beat Cedric. Don't let him have the prize. Partitions. Data is copied to every node. Address locators through the mail. I'm very curious if you've paid attention to what we discussed today. It was a long story, 3 hours, but we gave you the answer. And partitions, right? Partitions.
Nice.
That is the right answer. Most of you made it. Not using address locator. I don't know what is it at all. It's just like it doesn't exist in Cassandra world. And the answer, data is copied to every node, is obviously wrong. Take a look. Apple is one of the most widely known companies. It has hundreds, thousands of Cassandra servers with hundreds petabytes of data. Can you imagine their cloud costs if they go to copy data to every node? First of all, it's not possible. Second of all, it's going to make bankrupts even of Apple. So no, partitions, not data copy to every node.
Let's see how Cedric is doing.
Hey, Cedric is on the second place.
Oh, man.
No? Ravi, hey!
All right.
You made it.
All right. Cedric is down to 4. Let's bring him down further.
Yeah, like don't let him get your prizes. Keep them for yourselves.
Yes.
Single issues, first place with 1,900 points. Ravi, fastest this question with 2 points difference to the first place. And Blair is also only 8 points difference to Ravi. That is a great job. Well done. Keep it coming. Next question. Question number 3. Answer fast to get more points. How do you scale Cassandra database? How do you scale a Cassandra database? Add faster hardware, increase the scale factor, add more nodes, stack nodes until they reach the desired height.
I like that.
Yeah, I mean, that's my favorite way to scale Cassandra. I can do it all day. Stack nodes. And the right answer was add more nodes. First of all, scale factor simply doesn't exist. And second of all, what you meant was replication factor, what defines replication, not scaling. So right answer is add more nodes. And we have 27 people who gave the right answers, 27 people from all over the world. And I see no mistakes by leaders. Stingle. Oh, no, what's going on?
We got to bring him down.
Stingle issues, you have only 4 points difference to Cedric. You have to take him down.
Yes,
and we have a new name, which is Brandon Barajas. Very good job, top 3. And Ravi, you have to, both of the Ravis, actually, you have to fight for the place in the top 3.
Yes.
Let's move on. That's question number 4. Answer fast to get more points. Cassandra database can be deployed on AWS only, any combination of on-premise and cloud provider, only one of the following: on-premise, AWS, Azure, on GCP, or live raft in case of emergency. Well, maybe with some Arduinos, why not? But the right answer was any combination of on-premise and cloud providers. Right, Cassandra is platform agnostic and vendor agnostic. You can run it everywhere thanks to open source community, Apache Software Foundation, and many developers putting their efforts into building such an incredible software.
Yeah, and since most people are Kubernetes, developers or operators here, I think for them, putting it on premise and every cloud is a natural answer, right? Yeah. So.
Right. Hey, take a look. Something just happened here. They together throw out Cedric from the top 3, and that is a great result. He is out of the top 3 with single issues, fastest. Brandon Barajas and Ravi, first of 2 Ravis on top of the leaderboard. That is incredible. But keep focused, like he is still very close.
Yes.
And that's the question number 5. So answer fast to get more points. Docker container is image of software stored on disk, lightweight standalone executable package of software, file used to configure a Docker instance, something to store fish in, then coming back from a day on the board. They didn't discuss it today, but you know what? It's KubeCon after all, and most of you made it right. Docker container is not an image of software stored on disk, and it's not a file to use it to configure a Docker instance. So there are multiple different definitions, but let me see. Oh my God! We just lost single issues.
Oh no.
That is okay.
Ravi. Go
Ravi. They made it to the top 2 places. That's incredible. And Brandon Barajas is still in top 3.
Don't you think Stinglicious can still come back? I think it's pretty close.
I think you see that. Well, that's not really close. The difference is like around 700 points. That's quite a lot. But I believe there will be some more mistakes by the leaders.
Yes.
So using those mistakes, maybe he still can fight. Don't give up. And take a look. Familiar name now. Black with the fastest answer recovers from his mistake on the previous questions. Okay, and we are getting close to the middle. Answer fast to get more points. In Docker, how do you enable persistent storage of application state? State service, volumes, persistent file layer. You don't persist storage. Storage doesn't exist. Nothing is real. Nothing.
I like what Tochu Kuo said, which is the last options are crazy.
And the right answer was volumes. Notice we here refer to plain Docker, not Kubernetes, not OpenShift, no nothing, just plain Docker. In Docker, you enable persistent storage of application with volumes, not with the state service. Okay, and I like it how 7 people support what nothing is real. I kind of can understand this point.
Yes.
But now let us see the leaderboard. Okay, Ravi managed to answer. I see Cedric, 5th fastest answer on the 5th place.
Wow.
And Valentina Ahiva made it to the 4th place, which is a great result. And Ravi occupying the first places. That's quite interesting. And Stinglicious is on the 8th place. Okay, at least he didn't mistake. Let's see, question number 7.
So we're on the second half now. So everything could change, right?
Yeah. In Kubernetes, what is a pod? A worker machine in Kubernetes cluster, a set of replicas, a group of 1 or more containers with shared storage and network. I honestly have no idea. which is technically can be right answer if you do have no idea, but we won't accept it, sorry, because there is a right answer right here. Okay, it was easy. Nice. Pod is a group of one or more containers, base unit of access in Kubernetes, and worker machine in Kubernetes cluster is a node, not pod. So most of you made it, but who was the fastest today?
Let's see who's fastest. Is things changing in the leaderboard?
Hey, Ravi, second Ravi made a mistake. That will bring him. Okay, so Cedric is back in top 3.
Climbing up.
Blair is very close. It's like 5th place. Stingalicious is keep climbing. It's the 5th place. And Ravi, Brandon Barajas, and Cedric Lundgren are doing the top 3 with Valentine, sorry, not sure, on the 4th place, getting very close to get to the top 3. Like, that's nearly not a difference.
5 or 6 answers, right? Questions to answer. So yeah, I think it could all change.
Yes, sure. Okay, and that's going to be question number 8. So answer fast to get more points. In Kubernetes, what is a service? A program what runs in the background. A policy what describes outgoing net traffic. And name it abstraction what defines a set of pods. Something you order in your room at a hotel.
I'll go with the policy of elimination.
No, okay, that wasn't easy. Service is not the policy, and service does not describe outgoing net traffic, and that's not the program what runs in the background. In Kubernetes, service is a named abstraction what defines set of pods and load balancing and routing for them. So Brandon and Valentine are making mistake. That is, okay, Stingalicious is on the 4th place.
Cedric is back again.
And Vasco gave the fastest answer. Cedric is back again, and Ravi still holding the 1st place.
Ravi,
but yeah, Vasco is doing very well. Okay, so
Blair's recovered really nicely, right?
Yes, that's a great job.
Yeah.
Question number 9. Answer fast to get more points. Kubernetes operator helps create a custom image, extend the types of application what can run on Kubernetes, deploy volumes, ensure your phone calls get routed to the correct destination. That's a hard one. I expect a lot of mistakes here. Oh, no. You still may surprise me.
That's pretty good.
Right. Kubernetes operator work is to extend the type of application what you can run on Kubernetes, indeed, and make deployment of this application simple.
And that's where you saw kind of like data center, the Cassandra data center. So when you did a kubectl get pods, you could get all that,
Right. So, that is interesting now because Ravi made a mistake. And now Cedric Lundgren is fastest again on the 1st place. What the hell? And Blair made it. Blair recovered.
Come on, we're all rooting for you.
Yeah, but now you have to take down Cedric. And Ravi is on the 4th place with Brandon Barajas on 5th. Oh, well, that is interesting. Now, that's question number 10.
Getting close.
Yeah. DataStax K8ssandra operator describes what network traffic is allowed for a set of pods, represents a customization of a particular Kubernetes installation, automates deploying and managing OSS Apache Cassandra or DC in Kubernetes. DataStax Cassandra operator is a support engineer who helps you with your deployment. Okay. Good. So no, DataStax Cassandra operator does not represent a customization of a particular Kubernetes installation. Frankly speaking, I'm not completely understand what this answer means, although I wrote it. But the right answer is Cassandra operator automates deploying and management for Apache Cassandra or DC in Kubernetes? That is the right question. That's the right answer. And Ravi, second mistake for both.
Looks like Blay is going to climb up.
Yeah.
No, not yet.
Yeah.
It's close.
Fastest answer, but still. But now Vasco is on the 4th place. And Brandon Barajas is just some points behind. Okay, Ravi, both of the Ravis are still on top 10. And that's question
Still
number 11.
Game, 11, 12, and 13.
Yeah.
Three questions left.
3 questions left, and I feel like all of you are getting nervous right now. So let's see what will happen in the end. Answer fast to get more points. What is the name of a service what automates repairs? Fixer, repair, cost corrector, equalizer.
Fixer, I don't think we went through
repair,
this much, but it was in the instructions.
Cost corrector, equalizer. Yeah, it was. I made sure we showing this thing. What's up? Hey, I did my job well, you see?
Very good.
Right, the right answer is repair. Cost corrector doesn't exist, as well as fixer and equalizer, at least not in the context we are working with today. So let me see the leaderboard. Okay, there are some changes. Looks like Cedric was slow. And Blair takes the 1st place again.
Nice, nice.
Delicious on the second.
Coming back. Nice work.
But now just, I want those Stingelicious, Vasco, and Brandon Barajas, and all the others to keep fighting to overtake Cedric. Yes. He doesn't belong to a top 3 on this leaderboard. That's for you. Question number 12. So answer fast to get more points. What would you use for backups?
Backups of
in this scenario. Yeah, of course. Backup operator, Stargate, Medusa. I don't need backups anyway. With properly configured Cassandra cluster, you may not be afraid even of disasters, like real disasters, but that's still better to backup your data to avoid possible mistakes. And here, backup operator doesn't exist. And Stargate is another tool, and it's not for backups. And Medusa is the right tool to schedule the backups for your Cassandra cluster.
I went through this pretty quickly where we did the Medusa secret and all that, but people were paying attention.
Yay.
Except Cedric.
So, yeah, Cedric didn't pay enough attention. And he gets to the 3rd place with single issues. Welcome back to the top 2. Nice. That is great result. Blessed, Delicious, Cedric, and Vasco are now the best, and actually Brandon Barajas are the best candidates to get to the top 3. And we have 2 questions left. Oh, sorry.
Last question.
We have one last question. Yeah. Last question. It will define everything. It will define everything.
Everybody's sweating.
So you know what to do. What is Stargate? Cassandra configuration tool, data API layer with multiple APIs, a TV series. It's a secret technology. I use it to get on Earth. Oh, now you will know my secret. Okay, so there were 2 right answers.
Nice.
It is the data API layer with document, REST, and GraphQL APIs, and it is a TV series indeed, so that is the right answer in this case. Stargate is not a Cassandra configuration tool, and yeah, it's kind of maybe a secret technology. I use it to get on Earth. That brings us to the final leaderboard, and looks like Cedric decided not to join, or maybe made a mistake, too tired after all.
He doesn't know what matters. Stargate.
Yeah, looks like. So
Blay.
We have Black at the 1st place. That is incredible result.
He was like 8 or 9 or something, and then slowly climbed back, right?
Yeah.
Wow, amazing.
He was in the beginning on top, and then he made a mistake, but he recovered and got to the top place. That's what I really like the most, is the ability to focus and recover, stand up again, if you fall.
Lucky.
Then stingel issues with the same story.
Yes, lucky 13 for all of them, right?
Yes, yes, yes. And finally, Vasco, who wasn't on top during the workshop, during the most of the questions, but keep consistent, good answers and used the mistakes of many others who was too much in a hurry and made it to a top 3. Isn't that incredible results? So Blair, Stingel Issues, and Vasco, please make a screenshot of your winner screen and send it to, where is my chat? Rex, could you please paste email for
yes,
Jack? Thank you. So make a screenshot of your winning screen, first 3 places, Blair, Stingel Issues, Vasco, make a screenshot of your screen, send it to jack.fryer@datastax.com. Link will be in the chat in a moment. And I have to say following. If you are on the top 3, you definitely have something to be proud of. You made great result. If you are in top 10, there were many dozens of people in this competition. So that's still great result. Better luck next time. We run 2 workshops per week, usually sometimes even more. And we have games on a lot of our workshops. So just jump in next time, youtube.com/datastaxdevs. We will be happy to see you there. And for those who are not on the leaderboard but participated in that, take a look. Our prizes are amazing, but let's say that's not Ferraris or villas. So you can survive it, I'm sure. But what matters, you stayed with us for 3 hours. You learned a lot of new today. And now with your skills, you can proceed with your learning, be a better version of yourself, better engineer, better application developer, or whatever your job is. And finally, you can have better salaries, better job positions, and so on and so forth. So that's much more valuable than DataStax t-shirt, let's say. Thank you for joining us today. And I have 2 more questions before we proceed to the next slides. First, how likely is that you would recommend this workshop to a friend or colleague? Hey, looks like we made it quite well. Thank you for the positive feedback. I know there are a couple of things what could be improved, and we will work to deliver a new version of this one with a better experience to the attendees. But still, thank you so much for the positive feedback. Now, I will keep this slide open. So even after the workshop, you will be able to write some comments. What did you like the most? What should we improve? Any open feedback? It will be great to have your answers, and thank you so much for answering. Meanwhile, we are switching to the wrap up and very last words. K8ssandra.io. It's the place to get together for all the people using K8ssandra. Sign up for the newsletter, participate on forum, join our Discord live chat, tweet and find us at Twitter with nickname K8ssandra. And finally, the main repository for everything is github.com/K8ssandra. Now, I've seen that in the beginning, there are a lot of people who are not certified for Apache Cassandra. Definitely makes sense. As you attended this workshop, you get the special exam voucher with 100% discount and 2 attempts for the certification. So with our academy.datastax.com, you can get through the preparations thoroughly for free. And then with this voucher, you can get for the certification, again, for free. There are currently 3 certifications available: Cassandra Developer, Cassandra Administrator, and K8ssandra specifically. Workshops resources are all located at github.com/K8ssandra/workshop. And of course, all the documentation is available on K8ssandra.io. Don't forget to catch us on Discord if you have questions. We will be happy to help. If you're interested to get even deeper, like very deep, if you are a real Kubernetes expert and want to get deeper with that, You may join Cassandra Kubernetes Special Interest Group with Cassandra operator discussions and so on. Meetings are bi-weekly. Past meeting videos are published at Planet Cassandra on YouTube, and agenda and minutes on Apache Cassandra Wiki. That's more for already Kubernetes and Cassandra professionals, so advanced level, let's say. And very important point, there is a special KubeCon talk this Thursday, October 14, how to put database in Kubernetes with our very own Jeffrey Carpenter, book author, courses author, and one of the best Cassandra experts. You definitely may want to attend these. Don't want to miss this session.
Yeah, and one of the nice things, if you go back, Alex, is this session is actually happening in person. So Jeff is going to be there, and maybe he'll be willing to autograph his book, or maybe do that whenever the book releases also. Okay.
Right. So this session is going to be beginner level. What are the persistent volumes, persistent volume claims, stateful sets, iterators? So this one is going to be good, very good for beginners. And for those who are already into that, on Thursday, October 14, we will have investigating multi-cluster deployments for data with Christopher Bradford from DataStax and Ty Morton from Google, taking your database beyond the border of a single Kubernetes cluster. That is going to be very interesting. And I'm personally definitely going to get this one.
This is going to be live streamed. It is not going to be in person because Chris decided not to travel.
Okay. Yeah, I can understand them. Now, DataStax booth at the KubeCon,
I want
our
this.
address.
Can I win this?
Yeah.
Can I win this? Not as a DataStax employee, I guess. But
yeah, you can't, sorry. Only our guests and you are the employee. So DataStax booth P15, visit our booth at P15 for K8ssandra demos and discussions, and get your chance to win an in-home dream arcade, and we will pay for shipping to your home. Enter to win the DataStax Dreamcade giveaway.
Yeah. And even if you don't win it, there are I think thousands of arcade games. So you can come, when you're feeling a little bit down after attending all the sessions and all that, just come and play some arcade games. It should be fun. And
notice that's
looking forward.
Oh, really? Great.
Yeah.
To be liable to win, you have to attend a demo in DataStax booth as an on-site attendee, or if you are a virtual attendee, you must attend the live office hour demo session in the DataStax virtual booth to be liable to win. Notice that's incredible. You can be on-site attendee or virtual attendee, and it still works for you.
And you don't have to be present at the time of drawing. We will ship it to you. All that you need to do, like what Alex said, is attend a demo.
Right. So we just done with Menti already. Your feedback is welcome. Feel free to catch us on LinkedIn. And thank you so much for joining us. It was a little bit of a bumpy road. Thank you so much for staying with us till the very end. You are the best of the best. And find us on LinkedIn. We will be happy to help you to take care of it all if you are curious.
Yeah, there's a question about where do I get the slides? Yes, it's going to be on the workshop link that you have.
Right.
You will have the PDF slides. It may be a little bit outdated, but we'll put the latest ones there. Okay.
Yep. Question from Anna Rodriguez. Which are the screenshots we will attach for submitting homework? It's explained in the repository. When is the exercises deadlines? There are no strict deadline, but we usually ask you to complete them within 1 week. Now, notice what workshop submissions are verified manually. So in some cases, it may take some time. Don't expect your submission to be verified within a couple of minutes, please. It may take some days even, considering work days, but I believe we can make it within this week. And as Cedric said, the link to youtube.com/datastaxdevs. If you liked this workshop, then you know where to find us for all of our workshops outside of the KubeCon. So,
and Audra,
I think we are done for
follow-up
today.
email with slides and the recording of the workshop will also be available. So you know, don't fret too much. You will get the links soon.
And I see many thank you. Good session in the chat. Thank you so much for attending. You are incredible. Now go take some rest. You do deserve it, but after that, go build something great. You can, and I hope we helped you to be better in that. Yeah. Have a great time.
I need to take a bio break as well, you know, so I really appreciate the fact that you have taken so long to stay with us, and despite some, you know, initial difficulties, I think we were able to, you know, kind of go through the whole thing. So appreciate the compliments as well. Mahajan, thanks, Rags and Alex. You know, yeah, we tried to do our best, and there are really, I mean, the whole team, you know, that you saw, you know, is out to deliver workshops and help you level up your skills. That's our simple agenda. Just wherever you are, level it up. Okay, and I myself am learning by teaching as well. So thanks again for carving out, you know, like 3.5 hours of your time. I know it's precious, and you know, if you have a chance, please stop by the booth, and I would like to thank you in person as well.
Okay, so yeah, you are lucky enough to be on the live event. Sorry for us virtual attendees or virtual speakers, it won't be the same. But from another point of view, today I speak at the KubeCon in North America. And on Wednesday, I speak at Smart DataCon in St. Petersburg. I believe I wouldn't be able to travel like that anyway. So we still have some nice chances.
Without leaving your room, right? You know, that's pretty much what.
Yeah, that's quite cool. That's quite cool. So have fun and thank you so much. And we hope to see you again at our talks and at our virtual booth. Thank you and have the best time.
Thank you. Bye.